Yo, what's up? It's not 11:30, it's PM. It's 11:30 AM. Alright, so my goal is I won't be going out with my friends. Hopefully, while still finishing. I know this much. I will review this. My goal is to finish up to here. Up to here, identity access management while still finishing what do you call that, tasks on the AWS skill builder. So 1 2 3, possibly this the services S3. So cloud computing concept. Okay, open a new window. uh AMP. They got Azure. They got Azure, bro. Okay, cloud computing types of top benefit. What I want is concept. Public cloud, private cloud, hybrid cloud. Introduction to. They got Google Cloud too. What the Okay. Understanding the type of cloud computing resources can be time consuming and costly. Enterprise needs to buy physical servers and other infrastructure through procurement process. Wait, wait. Okay, enterprise need to buy physical servers and other infrastructure through procurement processes that can me that can take months and support the architecture of cloud computing. The AC acquire system require a physical space, typically a specialized room with sufficient power and cooling. After configuring and deploying the system, enterprises need expert personnel to manage them. After configuring and deploying the system, enterprises need people management to manage them. This long process is difficult to scale when demand spikes or business expand. Enterprise can acquire more computing resources than needed, ending up with low utilization number. Cloud computing addresses this issues by offering computing resources as scalable on-demand service. Wait, this shit is way too quiet, bro. Wait, mm-hmm. Okay. One of this gave me a copyright, bro. What the fuck? Not this. This or something else. Give me a copyright. All right. Cloud computing definition is the on-demand availability of computer resources such as storage and infrastructure as service over the internet. It limits the need of individual businesses to self-manage physical resources themselves and only pay for what they use. The main cloud computing service model include infrastructure as a service, offers compute and storage services. Platform as a service offers develop and deploy environment to build cloud app. Service as a service delivers app as services. Okay, that's basic understanding how cloud computing work. Cloud computing service work models are based on the concept of sharing on-demand computing resources, software, and information over the internet. Or individual pay to access a virtual pool of their resources, including compute, storage, and networking services, which are located on remote servers that are owned and managed by service providers. One of the many advantages of cloud computing is that you only pay for what you use. This allows organizations to scale faster and more efficiently without I know that much. Okay, they can like rent and only pay for what they use, bro. So like it's really easy. Okay, let's do this. Okay, in similar terms, cloud computing use a network to connect user to cloud platform where they request and access rented computing service. A central server handles all the communication between client devices and servers that, that contain the actions of data. Security and privacy features are a common component to keep this information secure and safe. When adopting cloud computing architecture, there is no one size fits all. What works for another company may not suit you and your business needs. In fact, this flexibility and versatility is one of the hallmarks of cloud, allowing enterprises to quickly adapt to changing market or metrics. Three different cloud computing deployment model: public cloud, private cloud, and hybrid cloud. Okay, public cloud. What the fuck is public cloud, bitch? Okay, what the fuck? But I trust Google. Fuck Microsoft. Okay, that's this much. Public cloud is a type of cloud computing when resources are offered by a third-party provider via the internet and shared by organization and individual who wants to use a core system. Some public cloud computing are available for free, while customers may pay for other resources through subscription or pay-per-use pricing model. For artificial intelligence services and and developer tools, user storage and computing capacity for any virtually any workload. Public cloud helps companies to harness cutting edge technology and achieve lower scale without shouldering the cost and labor themselves. Public clouds contrast with private cloud models where the resources are available only to single organization. Contrast with private cloud model where the resources are available only to a single organization and the data center is managed either on premise or off-site by a vendor. For organizations looking for an alternative to traditional on-premise IT architecture or other type of cloud computing, the public cloud offers nearly infinite scalability and self-service provision to meet workload and user demands. Okay, cloud computing is like Google Cloud, AWS, Azure, and stuff. Public cloud is an IT model where public cloud service make providers make computing services, including compute and storage, development and deploy environment and application available on demand to our organization and individual over the public internet. Yeah, private is like for specific infrastructure of the company, but public is for everybody throughout the internet, independent is where it is hosted and who is responsible for managing it. Public cloud uses their infrastructure while private cloud usually organizes own dedicated infrastructure. Other common cloud models include hybrid cloud, which combines public and private cloud, and multi-cloud, where customers employ cloud services spanning multiple public clouds. Wait, I need to understand what is private cloud. Okay. Why is this so more? Okay. Is a cloud computing deployment model where all cloud resources are dedicated to a single customer or organization. User organization private cloud, sometimes called internal private cloud or corporate cloud, which provides many benefits of cloud computing um, environment, including scalability, flexibility, and faster service delivery. At the same time, private cloud are single tenant, allowing customers to maintain the same level of security, access control, and customization they had with on-premise infrastructure. Okay, traditionally Targa were run on-premise, but it now possible to run private cloud services using rented infrastructure in a cloud service provider. What the fuck? Okay, hybrid, and then we will go to the difference between them. Okay. Hybrid is kind of longer. A hybrid cloud is a mixed computing environment where applications are run using combination of computing, storage, and services in different environments, public cloud and private cloud, including on-premise data centers or edge uh, location. Hybrid cloud computing approach are widespread because almost no one today relies on a single public cloud. Enables you to migrate and manage workload between these various cloud environments, allowing you to create more versatile setup based on your specific business needs. Many organizations choose to adapt cloud hybrid cloud platform to reduce costs, minimize risks, and extend their existing capacities to to support digital transformation effort. A hybrid cloud approach is one of the most common infrastructure set up today. Cloud migration often naturally lead to hybrid cloud implementation as organizations often have to transition um, application and slow data slowly and systematically. Hybrid cloud environment allow you to continue using on-premise service while taking advantage of the flexible option of for storing and accessing data and by public. Okay, on-premise service is like physically they have it. They can store in the cloud too, bro. They include application or the components such as include application on when deployed across public and private cloud. On-premise servers are often referred to as private clouds. Okay, private example. The most common hybrid cloud example is to use public cloud with private cloud services and on-premise infrastructure. However, there is no one hybrid configuration or one size fit all architecture. On-premise is private, bro. Okay, hybrid cloud could combine a public cloud and a private cloud running on premise or on the edge. It could also combine a public cloud with another public cloud, multi-cloud. Hybrid model are meant to allow an organization to mix and match environments and to choose what works best for the specific application and data. For instance, hybrid solutions are popular with companies in highly regulated industry. They have strict data privacy requirement for how they store, process, and interact with their data. Another common example is adapting a hybrid cloud approach when transitioning to using a public cloud to scale capacity dynamically when computing or processing demands it. Uh, okay, that's kind of smart. Any cloud migration project inevitably leads to hybrid cloud deployment as workload and the applications are slowly and strategically shifted over to the cloud. This is hybrid cloud and multi-cloud. Okay, while this term are often used interchangeably, they are not quite the same. Hybrid cloud physical interconnect public and private cloud working together, sharing data and problem. On the other hand, each services from more than one public cloud for various tasks. Where they also organization they do not want to depend on single provider may choose to use resources from several providers to get the best benefit of each services. Okay. Hybrid. What the fuck? Hybrid cloud approach can be considered multi-cloud if it includes resources from private cloud and resources from at least two public cloud services provided. In other words, multi-cloud setup include setup. Okay, how does it work? Hybrid cloud work by combining the resources and services from two or more separating computing environment. Hybrid cloud architectures require integration, orchestration, and coordination so you can share, save, and synchronize information quickly. Managing strong hybrid cloud is critical. Strong hybrid cloud network is critical for hybrid cloud deployment. Monitoring the interconnectivity between environments is typically started using lots of private network. It's for the advantage of the skills and security of private public clouds such as Google Cloud. Bro, they grab right AWS, bro, while keeping your data on premise to comply with data residency law or supporting computing needs closer to your customer. For some of you, critical system operating in a private and public cloud, hybrid computing is a great option. Okay, when hopping on, you can manage your application to the cloud at the speed that makes sense for you. Yes. Maintain regularity compliance. Many industries have rules surrounding where your app can operate hybrid. Yeah, I was thinking about this. Have to invest in both of them, like from private and public too. Yeah. Bro, AWS will it survive all the competition or not? I don't know. How to set up a hybrid cloud? Define your vision. Create a vision statement that evaluates your current approach and environment to help you define what you want to optimize and how hybrid or deploy it. And understand. Fuck this then. Generally, there are three types of clouds you can choose from. We're selecting a cloud deployment model: private cloud, public cloud, or hybrid cloud. Single tenant environment where the cloud resources and services are dedicated to the single organization. Private cloud and cloud computing are typically hosted on premise in an organization data center, but they can be run off premise or increasingly on IT infrastructure rented for a cloud provider. Public cloud is multi-tenant, meaning all the cloud resources and services are shared between multiple customers, typically hundred or even thousands. Unlike private cloud, public cloud resources are owned and operated by a third-party cloud provider such as hybrid cloud, e-commerce. Now that, bro. Okay, there are type of private cloud. There are many types of private cloud, including on-premise private cloud, virtual private cloud, hosted private cloud, and managed private cloud. These type of private environment differ from each other depending on who manages the system, the environment, and where it is hosted. Each private cloud type offer various benefit and uh, function based on your organization needs. Let's take a closer look at each type of private cloud. On-premise private cloud. On-premise private cloud are initially hosted in your data center and managed by your IT team. And on-site private cloud offers high level of control over data privacy, security, and customization, but capacity is limited to your available available infrastructure. Virtual private cloud or private cloud VPC offers private resources and an isolated environment using shared public cloud resources. With a VPC service, you can control, define and control the private cloud using shared resources with a VPC service. You can define and control a custom person made that is actually ready to okay, that this is I think BBC is like on the feature of public cloud. You can make a public cloud or private or first private resources and isolated using shared. Okay, got you, bro. Got you. I know that, bro. Like the fuck. Alright. Okay. Is BBC feature or public cloud? With the platform logically. Yeah, I knew that, bro. Yeah, I knew that. Private On-premise private cloud, hosted private cloud, private cloud hosting are run off premises on a third-party vendors cloud services. However, unlike a VPC, you don't have to share with other customers, and instead, private cloud servers are used by a single organization. Hosted private cloud service offer more resources and high demand scalability. Hosted private cloud or private cloud. Hosted private cloud or private cloud hosting are run off premises on a third-party vendor cloud servers. However, unlike a VPC, you don't have to share with other customers, and instead, private cloud are used by a single organization. Yeah, okay. Hosted private services offer more resources and high demand scalability options like the fucking AI are using. They are not using AWS and stuff. They are using their own cloud services, bro. In addition, the service provider owns and manages cloud resources, including maintenance of updates and security management. Managed private cloud. Managed private cloud are typically hosted single tenant environment, but they can also be located on premise if your organization will particular are not shared with a fully managed private cloud. A third-party provider is responsible for deploying, configuring, managing maintaining the private cloud, including the software network and operation providers may also offer other services such as identity management, storage, or backup. Okay, customers more control, increase security. Okay, I understand this. Not that. Okay, nah, public, this and this. I understand them. However, it's a combination of private and public, like they use like uh, private resources plus the public AWS resources and stuff. And private can be like VPC, which is a feature of public cloud but includes as private cloud. Okay, that's I read this about I read this, but I kind of forgot about the hierarchy or something that was in my book or something in my computer book. Cloud deployment models, cloud service models. What the fuck is them? Cloud deployment models. Yeah. Three type of infrastructure as a service offers an infrastructure offers undemanded access to IT infrastructure services, including compute store and networking and virtualization. It provides the highest level of control over your IT resources and more closely resemble traditional on-premise IT services. Private platform as a service offer all the hardware and software needed for cloud application deployment with PaaS. PaaS platform as a service company can focus fully on application deployment without burdening or managing and maintaining the underlying infrastructure, bro. Software as a service. This is like full stack development for underlying infrastructure. Underlying infrastructure to maintaining and operating to the app software itself as software as a service solution is often an end user application where both the service and infrastructure is managed and implemented by cloud service provider in terms of cloud service. What the fuck is problem? I need to watch a video too, bro. Type of cloud service. Platform as a service. What the fuck is in the... Yes, I'm talking about this, bro. Where the fuck is the song playing? Oh yeah. Wait for a second. Let's look at this. This is the same as other.
Hello guys, welcome back. My name is Adam and this is the fifth episode in Azure Fundamentals course. The topic for today is cloud service models. What are their differences and what are their key characteristics? Stay tuned. As always, at the beginning of the episode, let me start with the session objectives. So what is being tested during the exam? In this section, you need to understand what exactly is infrastructure, platform, and software as a service, but also understand them well enough to be able to compare and contrast them between each other. And to better understand that, we need to first understand what exactly is considered infrastructure, platform, and software. And for that reason, I prepared you a very small exercise, an example. So let's imagine we are a startup company and we want to host our own application and build entire infrastructure for that reason. Of course, the first thing we will need to do that is to purchase some servers. So all the hardware that will actually run the applications themselves.
Yes.
Obviously, our servers need to be able to connect to the internet. Therefore, we will need to provide all the networking infrastructure as well, including the internet connectivity itself. And because every server needs a storage, you will need to additionally provide a storage infrastructure whenever those are hard drives or solid state drives, some RAID itself. Our servers need to be able to connect to the internet. Therefore, we will need to provide all the networking infrastructure as well, including the internet connectivity itself. And because every server needs a storage, you will need to additionally provide a storage infrastructure whenever those are hard drives or solid state drives, some RAID, RIs, and things like that. You need to provide that additionally. Once this is in place, you have all the hardware needed in order to run the server. Now, in order to ensure the best utilization of the hardware that you have, you will want to run some virtualization software so that you can run multiple virtual machines on a single hardware piece. So software, best utilization of the hardware that you have, you will want to run some virtualization software so that you can run multiple virtual machines on a single hardware piece so that you can host multiple applications but still maintain the total separation of the environments. And virtualization software will allow you to do that. At that point, you will start creating multiple virtual machines in order to host your applications. All those virtual machines will need an operating system, whether that's Windows or Linux or any other operating system on the market. Once the operating system is in place, you will additionally want to install a middleware, which typically means all the software additions that you need in order to run the system and the application itself. And a typical application will additionally need a runtime, so another layer of the software which will host your application. If this is a web application, this could be IIS Web Container. If it's a container application, then maybe a Docker. But runtime is additional layer that you will need to maintain yourself. Once all of those layers are in place, we are now finally ready to host our application and application data on that system. While there are quite few layers on the screen, a few clear distinctions can be made here. The first four layers from the bottom are so-called infrastructure. So all the layers that directly are related to the hardware and the virtualization. Next layers can be grouped are platform layers, so operating system, middleware, and runtime. So all the software, all the system and configuration that is required for you to run the application, but not the application itself. And the last part, the application and the data itself, is so-called software layer.
This is programmers. This is what programmers do. Maybe Docker, but this is platform. Okay.
The as a service part of our episode means who will manage what. If you manage all of those layers, that means we're talking about the on-premises. So the clear ownership is on you. You manage all the infrastructure, platform, and the software. And cloud provider is not even involved. But if you decide to platform and the software, and cloud
ownership, you manage everything.
provider is not even involved. But if you decide to outsource the infrastructure, purchase the infrastructure from the cloud provider, so let Microsoft manage the infrastructure while you manage the platform and the software, this is so-called infrastructure as a service. So the ownership of that part goes to a cloud provider. In this case, Microsoft will manage all the networking, hardware, and the virtualization itself, while you will manage the platform and the software part. Typical use cases here are migration of the workload from the on-premises, testing and development, but also extending your on-premise environment with the capacity of the cloud so that you can create storage, backup, and disaster recovery scenarios. The list of services used in Azure to implement infrastructure as a service solutions is quite long, but typically you will see things like virtual machine, virtual networks, managed disks, or one of many services that you can use for this purpose. But in general, the rule of thumb is, if someone says that they have infrastructure as a service solution, that means they have a lot of virtual machines, and probably this is the skills they're looking for. If you're designing for the cloud, you most likely will go one level up, so you will allow Microsoft to manage the platform and the infrastructure part, while you just build your own applications. In that case, we are talking about platform as a service. In this model, cloud provider will manage the infrastructure and the platform, so besides the hardware, Microsoft will need to manage operating system, all the security patches, all the middleware, and the runtime to host your application. And you will only need to build and manage your own applications. Typically, this model is used whenever you're developing cloud applications. This could be a state-of-the-art web applications, AI, machine learning, business analytics solutions, well, pretty much anything. If you're building applications, you're most likely using platform as a service solutions. In this case, we can talk about SQL for relational databases, app service for web hosting, logic apps for enterprise integrations, function apps for serverless,
SQL.
or one of the dozens or even hundreds of other services allowing you to take advantage of cloud in a platform as a service model. And if you decide to outsource everything to Microsoft, that means you are using software as a service model. In that case, the ownership of the cloud provider is everything and there's nothing on you. You could think what would be the case of software as a service? Usually this means buying off-the-shelf applications. Applications like Outlook, Skype, OneDrive, and all the other business applications that you're probably using every day. This is software as a service, so Microsoft manages everything and you just use the applications. I will now summarize the differences between those service models, but from a little bit different angle. If you let cloud provider manage the physical data center buildings, networking, security, servers, and the storage, we are talking about infrastructure as a service. If that cloud provider additionally manages the operating system and the development tools, we are talking about the platform as a service. But if that cloud provider additionally manages the applications and the data, we are talking about the software as a service. Maybe this view will let you better understand the scope of responsibilities for each of those service models. And that's pretty much it. If you want responsibilities for each of those service models. And that's pretty much it. If you want to summarize what you learned, go to my website to episode number 5. Check out the study guides with official links.
Okay, I understood that well. Oh, the cloud practitioner taught me this, and SQL was or platform as a service was introduction coming up introduction. Cloud deployment model. What the fuck is that, bro? Okay, multiple.
Hi, my name is Bruno Breezy.
Hello guys, welcome back. My name is Adam and this is the sixth episode in our fundamentals course. This time we will be talking about cloud deployment models and their key differences. Stay tuned! In our previous episode, we learned about service type models. This time we will be learning about the deployment models. This section of the exam will test you whenever you know what is a public, private and hybrid cloud and what are their differences. Let me start with a public cloud. In order to understand the public cloud, we need to make a very clear separation of where we are deploying our services. We are either deploying them to the cloud service provider or inside of our own data center. When it comes to the public cloud, that means all our resources are hosted in a public cloud. That means we don't own our own hardware anywhere. One thing to note is that in public cloud, some services share the hardware with other customers. This usually is solved by just picking the right pricing tier, but you should be aware of that when you're starting with the cloud and you have some security compliance policies in place. So public cloud is very simple to understand in general. You're hosting everything in public cloud. As in any deployment model, there are always advantages and disadvantages. In this case, when it comes to advantages, there's no capex, there's no capital expenditure. That means no big initial investment on your side. With cloud being highly available and agile by default, you get those all advantages by just simply going to the cloud. Thanks to pay-as-you-go pricing and this consumption model that we're talking about, you only pay for the resources that you use. And because Microsoft manages all of the hardware, there's no hardware maintenance required, and as such, no deep technical skills required from your teams. While there are some disadvantages, there's one major one when it comes to security and compliance. Because while cloud is secure by default, there may be specific security requirements or government policies, industry standards, or legal requirements that the public clouds cannot meet. In that case, the public cloud might not be the right choice for you. There's always an issue with ownership, because if you want to maintain your own hardware or make changes to the hardware, then again, you cannot do that, because Microsoft is hosting all the hardware and managing all the hardware within their own data centers. And if you have some specific unique business requirements, then again, public cloud might not be the one for you. And on the other hand, we have private cloud, which is reverse model. You don't have anything in public cloud, you host everything in your own data center. In here, remember that you need to provide a self-service in order to be actually considered cloud, and you need to provide all the benefits of the cloud except in your own data center. In this scenario, you are the one maintaining all the hardware. So let's talk about the advantages and disadvantages of using private cloud. The advantages are pretty obvious. Because you maintain everything, you have all the possibilities, so you can support pretty much any scenario. You have total control over the security, and as such, you can meet any security and compliance requirements. But maintaining your own hardware comes at a cost, and that cost is a big initial capital expenditure investment that you need to make. So it's mandatory when running private cloud. The third model, which is a hybrid model. In this model, you take advantage of both public and private cloud. You connect them together to provide the greatest flexibility out of those three options. So when talking about the advantages and disadvantages, the obvious one is the great flexibility. But beyond that, you can run legacy applications in your private cloud, utilize existing infrastructure, meet any security requirements, but for everything else, move to the cloud and take advantage of all the good stuff from the cloud. In this case, the disadvantages are pretty obvious. Bigger environment consisting both public and private cloud might be more expensive, but is definitely more complicated to manage, and as such, puts a bigger strain and bigger requirement on the skills and expertise of your internal IT teams. But that's pretty much it when it comes to those three models. If you want to learn more, go to my website to episodes, the cloud deployment, and expertise of your internal IT teams. But that's pretty much it when it comes to those three models. If you want to learn
The service model is this. Okay, service models. Okay, what we provide virtual hardware, platform framework, fully deployed and developed software application, abstract event, management, OS, customers on high scale it. Okay, cloud computer deployment model, the different approaches in managing and setting up the cloud services, including cloud computer deployment models such as private, public, hybrid, community, and multi-cloud deployment. Bro, this bitch ass baby is crying, bitch. Oh, okay. Um, I know there's cyber, private enterprises, and plus cloud. I know there's community Q cloud, community distribution system created by integrating the service of different cloud to address the specific needs of a country, industry, community or business sector, but sharing responsibility among the organization is difficult. In the community cloud, the infrastructure is shared between organizations that have shared concerns, tax, and organization or third party may manage the cloud. The fuck? Wait the fuck up. Listen, cloud. In the what is cloud? Cloud company is shared by multiple organizations. I will just say, who uses this, bro? Okay, okay. Academic self forces, okay. Okay, come dedicated for community users. Oh, okay. I get that right now. Okay, because the entire cost efficient because it work with every user of the community. Scalable and adaptable. Thankful. In media industry, like mangas and anime which are pirated, like they have the same cloud. I think then they got the same community cloud. By the way, I think like 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 I went across 9 different manga website which has a same rendering mistake. I think it's from the cloud then. Like they use a community cloud, I think then. And anime industry like pirated one. They use media industry, I think. Media no community cloud. Why did I lag for a second? Is the use of multiple cloud services for different providers, which allows organizations to use the best suited services for their specific needs and avoid vendor lock-in. Multi-cloud, I know this. Kubernetes, Red Hat, OpenShift. Okay, I think multi-cloud is the way to go, bro. Like you can like take advantage of many stuff of one service with along with other service. I think that's a win-win situation in my book. Deployment model, service model, software as a service, platform as a service, deployment model. What the fuck is this? Cloud deployment model, cloud. Mm. Oh, deployment model. Bro, it's in its name, bro. What the fuck am I so dumb? Okay. Mm, we did this. Okay. I need to change the time, bro. Wall clock. Um, mm, and this is my country. Star Wars timer. Nothing. Okay, can I see Kathmandu here? 11:14. We are starting way. Okay. I think I told this AI that I don't know Git that well, but I can commit by GUI, not CUI. Come on. Okay, AWS reasons, a valid zone. I know that's a valid, but I can go a little bit in there. Like, wait, I need to eat dinner, so it's gonna be like, oh yeah, 1:30 or 1. So pause. Yo, I stopped around 12 or something. It's 5 p.m. Alright, fucking hell. So this is the availability zone of AWS service. So my country is here, just below Thailand, just above India. There's two, Hyderabad, Mumbai, okay, Thailand, Malaysia, Singapore, Asia Pacific, Midland China, Hong Kong, Taipei, or something, Beijing. Alright. USA, Mexico, Central. Okay, there are many options, bro. Span 123 availability zone with 39 geographic region. With all announced plan for 2 more availability zone and 2 more AWS region in the Kingdom of Saudi Arabia and Chile. Alright, bring one in Nepal, bro. What the fuck is location, bro? What is and location is a specified data center in a major city used by cloud provider to catch content closer to end users, significantly reducing latency and improving data transfer speeds. Okay, got you, bro. Okay, Philadelphia, draw capital, bro. Chicago, Dallas, Texas, Fort Worth. What is some of this? Some family member are in there. Okay, what I want to know is one. What the fuck? Okay, AWS reasons. Okay, and the place where they go, the fucking infrastructure is what I did. Red. Okay, is location, major centers. Okay. Availability zone. I know that stuff, bro, but I'm gonna read that stuff again. Concept of a region, which is a physical location around the world where we cluster data center. We call each group of logical data centers. Am I being too loud? As we call each group of logical data center. We call each group of logical data center and availability zone. Each AWS region consists of minimum of three isolated and physical separated availability zones. Separated. Each AWS region consists of minimum of three isolated and separated, physically separated availability zone within a geographic area. Unlike other cloud providers who often define a region as a single data center, the multiple availability zone design of every AWS region often offers advantage for customers. Each availability zone had independent power, cooling, and physical security, and is connected via independent power, cooling, and physical security, and is connected via redundant ultra low latency network. AWS customer focus on high availability can design the application to run multiple availability zone to achieve even greater fault tolerance. AWS infrastructure regions meet the highest level of security, okay, compliance and data protection. AWS provide a more extensive global footprint than any other cloud provider, and to provide a global footprint and ensure customers are served across the world. AWS opens new regions rapidly. AWS maintains multiple geographic regions, including regions in North America, South America, Europe, China, Asia, Pacific, South Africa, Middle East, which is all the world with cluster of data centers. The group of data centers secure region. Okay, I get that. Geographic region, this should include Mexico, yeah, right? So easier to rock. Let me clarify if I'm right or wrong. Its location is the most, what they call that, develop or more end-to-end user, so that they can utilize the what they call that, utilize uh, with more connectivity and stuff. Africa, Kenya, China, Philippines, but not Nepal, bro. Okay. Nepal is looked over. Is the EWI. Blossom in multiple with multiple available but in reason, yes, reason in reason. But it feels like it, they have one. Okay, I wanna see what Asia is. List of Asia. Okay. What the fuck is nearest to me, bro? Talk to me. South India. That might be closer. Bro, where's the fucking GY in this, bro? Wow. Why the fuck is there so many of it? South India, Central India. This is my country, bro. Within this too gigantic, bro. Oh man. Okay. Bro, there is corruption in this. Just joking, bitch. I like this. Why the fuck do I like this? Nothing, bro. Oh, why did I do that? Bruh, okay. Bruh. Another zone is one or more discrete dozens with redundant power network and connectivity in an Amazon AWS region. Every zone give customer the ability to operate production applications and database that are more highly available, fault tolerant and scalable than would be possible from a single data center all available zone. In an AWS region are interconnected with high bandwidth, low latency network over fully redundant dedicated metro 5 product providing high amount of one or more discrete data center with okay and available zone. And AVAR VZ is like group of data center. I don't know how to write reasons. Bruh. What the fuck am I saying bruh for, bro? I'm not a fucking kid. What the fuck? It's not just one single data center, it's one or more discrete. That's what I'm saying. Or a group of data centers. That's the fuck I was saying, bitch. Bro, what the fuck is he talking about, bro? I understand this. Reason is understand this. Share responsibility moral like if one goes down, other keeps pricing concept support man. What the fuck? Is this supposed to be a lag? Okay. Dang, where the fuck did that go? Okay. No more local zones. Local zones. Output services. Okay. Please computer store. Others like AWS service. To end to end with AWS local zone, you can easily run highly demanded application that requires multi-digit millisecond latencies into your end users such as media and entertainment content creation, real-time gaming, whenever reservoir simulation, electronic design, automation, and machine learning. Each AWS local zone location is an extension of an AWS region where you can run your latency sensitive application using AWS services such as uh, EC, EC2, EC2, bro. Amazon Virtual Private Cloud, Amazon Elastic EBS, bro. EFS, file storage, and Elastic Load Balancing. Okay, I understand with that, bro. What the fuck? Services. Okay, I know, bro. I need to learn about this. So that's it. Fucking hell. That's it. Data centers service. I looked it up in the meantime when I was learning from AWS Cloud Practitioner and shared responsibility model. What the fuck is that? Oh, if one goes down, other shit will still be up or something. Share responsibility model. Okay, I want to mess around here, so like AWS, what do you call share responsibility model? Cloud security, bro. What the fuck? It's a good job to have, bro. Not gonna lie, bro. But I need to become a cloud engineer first. What I want to do. Okay. Share responsibility model. Okay. Let me get a video in that. Oh fucking hell, I didn't double click. Okay.
Concept known as the A. Hey guys, in this lesson I'm going to cover a concept known as the AWS Shared Responsibility.
Wait the fuck up, he's a good YouTuber. He got that from the skill builder. I'm not gonna. Okay, DevOps.
Everyone's telling you to get AWS certified, but here is what nobody mentions. Half of these certifications won't actually help you get hired, and some might even waste months of your time. I'm Suleiman. I've worked in tech for more than a decade. I run my own consultancy, and through my academy, I've helped more than 700 IT.
Okay. What the fuck is S tier? Architects, networking, cloud practitioner, Azure beginner, solution architect. Is solution architect kind of good? Security is
both
must be
go
yes.
into S tier. So the final tier list: S tier, solutions architect associate and professional certification, security specialty and machine learning specialty. A tier, generative AI development professional, advanced networking specialty, machine learning associate. B tier, cloud practitioner, AI practitioner, DevOps engineer professional. C tier, data engineer associate. D tier, developer associate. F tier, cloud ops. And if you want to pass any of these AWS certifications faster without wasting, this is exactly what AI with more longevity. The market is shifting weeks, will you way better off. Now, they have mountains of data sitting in the cover. Number 2, market demand. Are companies actively looking for it? Number 3, difficulty versus payoff. Is it time investment? Might be pointless for a C levels: foundational, associate, professional, and specialty. So let's start with the AWS Cloud Practitioner. This is the most foundational certification that AWS offers, and it teaches you the business side of cloud. For example, why companies actually migrate to AWS in the first place. You're being introduced to cloud computing and different terminologies like the shared responsibility model. Now, all AWS certifications that we're going to cover, this is definitely the easiest to pass. And here is the bonus that most people don't realize. When you pass any AWS certification, you get a 50% discount voucher for your next exam. So this can become your entry point that makes everything else cheaper. Now, if you're already in IT and you're looking to pivot into cloud, you could skip this one, but it's still worth getting as it's an easy win. But for complete beginners with no tech background, this builds a foundation that everything else sits on, so don't skip it. And yeah, it's not going to get you hired on its own for beginners, but the ROI for your time is solid. Cloud practitioner goes into B tier. AI practitioner. The AWS AI practitioner teaches.
That's all I want to hear, bro.
Responsibility model. So this
Customer responsible for security in the cloud, customer data, platform application identity and access management, operating system, network, firewall configuration, system side data encryption and data integrity.
This is a graphics.
Integrity. How the fuck do I say that word? Integrity, fuck is something. Authentication, server-side encryption, file system, and or data, networking, traffic protection, encryption, integrity, identify AWS responsibility for security of the cloud. Okay, in the cloud. Okay, software, compute, store, there's database, network, hardware, AWS, global infrastructure, regions, availability zone is location.
Straight from AWS. This is a very important concept. You need to understand durably stored and copied. That's your data, it's your responsibility. Now, of course, underlying all this, for data, we've got storage, we've got databases, we've got connectivity services for transmitting data. AWS are supplying those services, and they supply the options for things like encryption, and they make sure that your data is durably stored and copied into different places. So you need to understand how they do that and what the levels of durability and availability are, but ultimately you're responsible for your data. Now, again, platform applications, identity and access management. AWS provide the identity and access management service, but you're responsible for creating users, creating groups, creating roles, creating policies, assigning the correct permissions. If you provide too many permissions and somebody does something that they shouldn't, then unfortunately that is your responsibility. That does become your problem. Now, underneath that, we've got operating systems. Now, here, in some cases, AWS will manage things like the patches of operating systems. So there are some examples of where that's a shared responsibility. But mainly, for example, if you're using the Amazon EC2 service, then the Windows or the Linux updates are something that you have to manage. Again, network and firewall configuration there. So AWS will provide the features for the networking capabilities like security groups, which are firewalls for EC2, network access control lists, and they give you the ability to encrypt your communications as well. But you ultimately have to utilize those resources and those features to make sure that your data is properly protected. So the three boxes in the middle here in blue, it's all about encryption and protecting your data at rest and in transit. All your responsibility. Underlying all this, of course, we have AWS, and AWS will provide the regions, the availability zones, the edge locations. Those are the ones for Amazon CloudFront, and they're going to manage all that global infrastructure, including the security of it. And then the various services on top of that. So you've got the infrastructure layer, compute, storage, database, networking, and more, and then all the software on top of that. So they are obviously responsible for that. They say that they are responsible for security of the cloud, and you're responsible for security in the cloud. So just to show you this in a slightly different graphic, here you can see the customer responsibility on the top and the AWS response.
It's so hardware stuff, bro. A network router, network switch, server, storage, hard disk driver, a database server, data centers, staff training, data encryption. We gotta do that. Security group. Who is there? EC2 instance means the server instance, server side, cell something, I am user role.
Responsibility on the bottom. So things like
AWS has been for years, by the way. I think I'm late.
Managing the data in your buckets. That's up to you, as is creating things like roles, setting up multi-factor authentication, configuring security groups and network access control lists. This is all a customer responsibility, along with things like patch management. And then underlying that, we've got the actual database servers, disk drives, physical network switches and routers, and the software layers, the control planes that sit on top of them. And of course, the data center security, that's no longer something you have to worry about. So that's the AWS shared responsibility model. There's much more information on this on the AWS website. It is important to understand this split of responsibilities so that you know what you're responsible for and what AWS will be providing.
What the fuck? What the fuck is this, bro? Bro, is this it free? Hey, no, bro. Per month. Fuck that, bro. Who the fuck gave you 4.9? From Google? From Facebook? From Amazon? LinkedIn? What the fuck is that? Bro. Okay, share responsibility, so like what the fuck? Where the fuck did that go? So I'm responsible for the services that I use, but and AWS or the cloud is responsible for itself, like the files, store files. What other is it called? File. Hardware, network, switches, hub or something. Okay, pricing concept. What the fuck? I'm gonna quickly pricing concept. Pricing. Bro, I need to learn this as a beginner, bro. And service pricing. Upward plan. That's offers. Pay as you go. I know that, bro. Pay as you go. Pay for what you use, bro. Oh, I forgot my laptop could bend 180 degrees, bro. Okay. Bro, I forgot about that. This is so nasty. Bro, my laptop is 180 degrees, bro. I'm shooked. Okay. 190 degree again. Okay. Not that. And pricing. Bro, 2016? What the fuck? 2013? Okay. Free tier is my shit. Is my shit. Free tier, bro. Can't do that. Access to all services. EC2. S3 bucket and stuff. Okay, support plans. So let's take this off. Okay, I'm allowing person done. But these are the fucking headache ones, bro. I know for a fact. I know subnet. I did subnet how to separate a fucking IP or the sub marks so that uh, they have full subnet in a network. But I didn't try it on mine because I don't want the DNS resolution. What the fuck is that? Don't do anything in here. TCP transfer protocol, IP internet protocol. I think OSI model operating system life cycle. I think. What the fuck is I, bro? No, firewall concept, firewall. I did Nmap. Like I will download Nmap. Wait the fuck up. This is fucking Debian, bro. I use Debian, bitch. Alright. What upgrade? Okay. I will download that. And Nmap. Nmap. The fuck? Fuck off, bro. Okay, balance mode. Oh, what the fuck is my Nmap, bro? Nmap. Ooh, ooh. I can't get over this, bro. Do 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 do. After switching to Debian, bro, or any other Linux, Debian was kind of being a friendly than Ubuntu, bro. Okay. What the fuck? Why the fuck is the Nmap not working, bro? I I want to install the app image, not the fucking other. Zenmap. I know that stuff. Zenmap. What the fuck? They have different ratings and stuff. Debian. Okay. Downloads is 5 total reviews and 11 total reviews. Why this one? Two launch in Fedora 37 operating system. This is the first time where USR bin slash env Python 2 in. Okay. People are spicy. All reviews. Who the fuck is using Fedora, bro? What even does Fedora look like? FED. Oh yes. Bro, this is it. Although it can be customizable, be pretty. Ultimate customization guide. Fuck you, man. Look at my shit, bro. Um, uh, okay, look at my shit, bro. This shit look clean, bro. Where the fuck is all the? No, not this. Shit has background, bitch. What do you think about this, bro? This shit look cool, but it doesn't go well with this. So okay. No network. What the fuck is this? Um. The fuck is even going on? What the fuck? Quit. Okay. The fuck? Why the fuck is this shit lagging or something? Okay. This shit look cool, bro. Have other stuff. Shares background set. I really like this one, but it doesn't go well with my theme. Kind of. Okay. Set as background. It's okay. It's okay, not that great than what I thought. Uh Themes are not that. It's in setting. Okay, okay. I need to charge this stuff. Appearance. Okay, this. Don't get me wrong. Debian is without customization, it looks whack. This was the fucking shit. This was the fucking wallpaper when I first joined. But this shit look cool, dude. Not gonna lie. But this stole my heart. I think this is cool too. Alright. Okay. It's okay. It's alright. This just look kind of minimalist kind of stuff. I think I'm gonna download Noark or something theme that look like arcs, which everybody have in Arc. Not Arc, Arts. Alright, bro. The fuck am I even talking about, bro? Wait, I need to go to the toilet.
DNS name resolution. What does it take to turn that awesome name, www.google.com or whatever name that you want, into into an IP address that your computer can use to, do the networking things that it does? Let's talk about it. So what exactly are we talking about? We are talking about when your computer reaches out to whatever DNS server it's been told to reach out to say, hey, what's the IP address for whatever domain name that I want to do? In our case, we're going to use the example of www.schetzler.net, my own website. And so what happens? First of all, your computer reaches out to the DNS server, whatever DNS server it's been told to reach out to, and it says, what's that IP address? The DNS server does not respond. Let me find out. It just goes and finds out and then responds. But we're, faking a conversation here. So you know how examples work. There are two different ways that can happen. The first that we're going to talk about is the full resolver process. This is what happens when a server goes through the entire process and figures out what that domain name is, what the IP address for that domain name is. And at some point, this has to happen no matter which process you use. We're just going to show this example first. The full resolver process, meaning we got to start from scratch. We reach a DNS server that knows nothing about this domain. So first, we have that DNS request that we talked about. So the computer reaches out and says, hey, server, what's the IP address? Where is www.schutzler.net? And the server, again, doesn't say, let me find out. There's no DNS message that's let me find out. The DNS server will respond once it has done its job. And that job starts with the DNS server reaching out to the root name servers. And it reaches out, it figures out where those root name servers are, to the root name servers. And it reaches out, it figures out where those root name servers are. Remember, DNS is a hierarchy, starts at the root. So we start at the root, and it has to know where that root is because it has a root.
Wait, before that, I think I need to learn about this. Because this guy has a DNS hierarchy and he is kind of fun to. I thought he was fucking retarded at one point, but he's kind of good at teaching stuff.
Do you want to get the AWS certificate for free? Here is the way. So easy. First, go search. Displayed here. You can click on any of the course. Then, do you find it helpful? Do you want to get the AWS?
But I don't like his accent bit.
Phone number and your web browser doesn't know it. But if you press enter, it does get there. What am I talking about? It's kind of like this. Actually, hold on. If I handed you an old phone and said, here, call your friend Bernard. Go ahead. Here you go, put the number in. You couldn't do it. You don't know Bernard's phone number. We don't memorize those anymore. You just know his name, Bernard. But if you could, grab your phone, open up your contacts app and type in Bernard, boom, you would see his phone number and then you could dial the number. Oh, that's really fun. That is DNS, the domain name system. Your browser doesn't know Bernard's phone number or the IP address for academy.networkchuck.com, so it has to check its contacts. And in this case, that'll be a DNS server. A server that's similar to your contacts app will map domain names or website names to an IP address. Bernard's name, Bernard's phone number. Website name, IP address. So your browser will query or ask the DNS server, hey, what's the IP address for academy.networkchuck.com? I gotta get there. And the DNS server will respond with the IP address, and boom, you're good to go. You can visit that website. This DNS process is vital to how the internet works. Without it, websites, emails, and pretty much anything to do with the internet would break. And it often does when DNS stops working, which often happens, because this process I outlined here is a bit more complex than I've shown. Also, this process can be hacked. There are ways to secure yourself. I use Secure DNS from TwinGate, the sponsor of this video. TwinGate is my VPN replacement, and they have amazing DNS features. We'll talk more about them here in a bit. This is going to be fun. We're going to trace all the DNS queries that your computer will use to get to academy.networkchuck.com. And there's quite a few. You're about to see how the internet works. So here we go. You open your browser. You're ready to learn because you want to go out to academy.networkchuck.com, where I teach on this and many other things like our new course, Intro to Laptops and Mobile Devices, part of our new A+ course, if you're just getting started in IT. Oh, and by the way, here's you. You're excited and you got a cup of coffee, so you're ready to learn IT. Let's get your refill. Coffee break.
Alright,
So you launch your browser and type in academy.networkchuck.com. Now before your computer goes anywhere, he might actually already know the IP address of academy.networkchuck.com. He'll use his stub resolver, which sounds hilarious. I love saying that. It's just the term for the DNS client running on your machine. But it's called a stub resolver. The stub resolver will check your cache, because if you've recently been to academy.networkchuck.com, the IP address might be there, stored in your cache for safekeeping. And if it is, you're good to go. You don't have to go out to a DNS server and ask it questions. But in this case, this is your first time. You've never been there before. That's crazy. How have you never been there before? Let's keep going. So your stub resolver knows he needs some help. It's time to ask his DNS server. His DNS server? What do you mean? Your computer will have in its network configuration, along with its IP address, a DNS server that it can talk to. This is something that you configure, or it's just given to you by the DHCP server in your network. What is that? You'll learn about that in Network Check Academy. Check it out. You're about to go there right now. A very common DNS server you might use is Google. They have a DNS server found at the IP address 8.8.8.8. It's one of the very few IP addresses I have memorized. So your stub resolver will send a query, a DNS query saying, hey, Google, my public DNS server. Surely you know the IP address of academy.networkcheck.com, right? And Google might go, actually, no, I don't. Wait, what? Yes, you see, Google's public DNS server is a recursive DNS server, which means he may not know all the IP addresses for every website, but he knows a guy who can tell him. He's going to make multiple requests to other DNS servers to find out. Are you ready for this adventure? I'm telling you, it's a crazy one. Now, sometimes he may not have to ask anybody because, similar to your stub resolver, he may have some cache. Someone may have already been to academy.networkcheck.com and he's got the IP address saved in his cache. And in that case, he'll just tell you, but we're going to assume he doesn't. So if Google doesn't know, then who does? Now, the next step involves some mafia bosses. Yes, DNS does have a hierarchy, and at the very top are the DNS mafia bosses. I'm not kidding, it's kind of crazy. They're called the Roots. That's for real. The Roots are run by these 12 companies, or organizations. Big names like NASA, the DoD, VeriSign. They control and manage 13 server groups, or 13 named authorities. And these are hundreds of servers strewn about the world. Here's the map. Oh, did I say hundreds? I meant 1,865. So Google will reach out to one of the root servers, the mafia bosses. Because surely if anyone, they would know the IP address of academy.networkcheck.com, right? Wrong. These are the bosses. They don't deal with the peasant work of domain to IP address mapping. No, they're all big picture. All they care about and know about are top-level domains, or TLDs. What is that? Well, when Google talks to these root servers, he's only asking about one thing. This section of our URL right here, the .com. This is a top-level domain, or a TLD. So .com, .net, .co, .coffee. These are all top-level domains. Also country-specific ones like .jp for Japan or .ph for the Philippines. Now what does it mean they handle the top-level domains? Well, it means they're lazy. They delegate everything. Meaning, they're not going to tell you any IP addresses for any domains, but they'll say, you know what? I know who can help you. Middle management, my underling. So what they maintain is a list of other DNS servers that can help you with these top-level domains. So in our example here, our Google recursive DNS server is only asking about the .com top-level domain. And our root server will return a list of other DNS servers that are responsible for that .com domain. And when I say responsible, I also mean authoritative. They're the bosses of those domains. Using NSLOOKUP, the query might look like this. And we'll pick one of the root servers here. I'll choose J. And we'll ask that Mafia Boss root server, hey, who manages the .com top-level domain? And the Mafia Boss root server responds with a database, a list of servers that are authoritative, responsible for the .com top-level domain.
NSLOOKUP type NS.
The .com top-level domain. And the Mafia Boss root server responds with a database, a list of servers that are authoritative, responsible for the .com top-level domain. These servers here, these DNS servers, are referred to as top-level domain servers, or TLD servers. But I want to make sure I'm labeling our journey here, the steps. So our Google DNS server asks for it, the root server responds. He says you can ask a.gtld-servers.net. He manages .com. Talk to him. So armed with that knowledge, our Google recursive DNS server will send another query to a.gtld-servers.net. Because surely he knows the IP address for academy.networkcheck.com, right? Wrong. He doesn't. It's a whole journey, I told you. But Google knows that. He's only asking about one very specific piece of information. This right here. Me. Network Chuck. This part of our domain is called the second level domain, or an SLD. So Google's not asking this TLD server, hey, what's the IP address for academy.networkcheck.com? No, he's asking, hey, who manages networkchuck.com? Who is the authority for that second level domain? And that's what top-level domain servers do. They keep a database or list of authoritative servers for website domains. I know, it kind of feels like a, I know a guy who knows a guy situation.
Here's the reality. Your college degree took 4 years and $100,000. AI skills, 28 days and $20. Guess which one your boss cares about more in 2020?
With NSLOOKUP, the query might look like this. and the .com TLD server will respond with an authoritative server or servers for networkchuck.com, the second level domain. And as you can see here, the authoritative server for my networkchuck.com domain is Cloudflare. That is who manages my stuff. So now finally, the Google Recursive DNS server knows who to ask. This whole process so far has been like, hey, to find out who might know. And now
Fuck, there's so much latency in that.
knows. The server is Cloudflare. His name is Pablo. I love their DNS server name server schemes. So Google sends one last DNS query. Please, sir, you're the last step on my journey. Do you know the IP address for academy.networkchuck.com? And guess what? Pablo does. Pablo does. Pablo knows everything about the domain networkchuck.com. He's got what's called the zone file, which looks something like this. Here's an example of a zone file, starting with a state of authority record, an SOA. Essentially, hey, who's in charge here? It's Pablo. He's the name server that you can contact to find out anything you want to know about networkchuck.com, including things like, and not limited to, the IP address for networkchuck.com. If you want to visit the main website, you should. It's really cool. And the reason we came here, the record for academy.networkchuck.com. And the IP address it belongs to, finally. Oh my gosh, it's here. And that's what Pablo responds with. Good old 104.18.42.139. Google has done it. He quickly updates his cache, saving that precious tidbit of information for later, and then finally he can tell us, our computer, our stub resolver, the IP address for academy.networkchuck.com. And by the way, the academy portion of this domain, to the left of the second level domain, this is called a subdomain, which allows me to do cool things like make an academy and point just that URL, that website name, to a different location, my actual academy, from my main website, networkchuck.com. Now, step back for a second and think about this. All of this happens every time you visit a website. It's magic. And it happens like that. Because when you visit a website you've never been to before, you just go there, no time really goes by, you don't even notice it. But behind the scenes, all this stuff is happening. That's so crazy. But you know what's also pretty stinking crazy? The fact that this process is often done insecurely. You see, when your PC, your client, your stub resolver queries a DNS server, it will by default use UDP port 53. This is done in plain text, meaning it's not encrypted, it's naked for all the world to see. So if I were a hacker, and I've demonstrated this numerous times on my channel, I could sniff or get in the middle of that traffic, take that traffic, and I could just look at it without any problems. I could see what websites to visit. If I really wanted to be bad, I could pretend to be a DNS server and respond with another IP address. Maybe an IP address that goes to another server that's bad. This is what happens all the time. It's called DNS spoofing. And it's not just the hackers you're worried about. Your ISP, your internet service provider, the person providing the internet can also see your DNS
Do that.
queries, which means
DNS snooping.
they can see what websites you're visiting. I don't want them to know that. Get out of here. That's why DNS security has become a pretty big thing. Thankfully, we do have a solution. We talk about how you can secure your own DNS right now. A big hero to the rescue was a thing called DOH, which is really cool. It stands for DNS over HTTPS. This is actually pretty crazy. So HTTPS, this is the protocol we use to securely access websites. So right now, as you're watching this video, you're on YouTube, and you're connected to YouTube via HTTPS. That connection is secure and encrypted. Hackers can't see inside of it. They don't know what videos you're watching. No one does, but you and that guy standing behind you. Watch out. So HTTPS is a secure encrypted connection. DNS, when it goes over HTTPS, also becomes a secure connection. So we get things like encryption. Even if the hacker happened to be in the middle of the conversation, they were sniffing your web traffic, they wouldn't be able to see that DNS query. So HTTPS is a secure encrypted connection. DNS, when it goes over HTTPS, also becomes a secure connection. So we get things like encryption. Even if a hacker happened to be in the middle of a conversation, they were sniffing your web traffic, they wouldn't be able to see that DNS query. It's hidden. Not only is it hidden, it's wearing a costume. It's wearing an HTTPS costume. You see, normally it's pretty easy to identify DNS traffic when you're looking at traffic captures. You can search for things that are using UDP port 53, but if DNS is using HTTPS along with all the other web traffic, I can't identify DNS traffic. It's just all website traffic. DNS is hiding in a crowd of people. It's like, where's Waldo? Except he's not wearing a bright shirt, he's just a regular person you would never know. Okay, this sounds great, right? So how do you use DNS over HTTPS? Well, the short answer is it's pretty easy. There are a couple considerations you have to know. For example, the client, your browser, has to support DOH, which thankfully most do nowadays. Also, the DNS server you're connecting to, the one you choose to connect to, also needs to support DOH. Choose a DNS server that supports DOH, just search that, Cloudflare, Google, they all have it, and make sure your client has DOH enabled. Cool, that's great for you. But what about your family? What about your employees? Are you going to go to every device and make sure they're using DOH and have the appropriate settings enabled and connected to the right DNS server? You could do that, but I don't have the time to. This is why I like to rely on tools like TwinGate. Now, TwinGate is my remote access solution. So when I'm out and about traveling the world, like I really use this when I was in Japan, or when my employees are working from home, like Florida Nick, this is what he uses to access our stuff here. He'll connect to our network in the studio using his TwinGate client from Florida, getting a super secure connection to us. That's cool by itself. You should definitely. So in their I can actually enforce things. They have what's Secure DNS. Let me show you what it looks like. I'm logging into my TwinGate dashboard. And by the way, I don't pay for TwinGate, and they don't give it to me for free. I'm using the free version right now. So in the internet security settings, I have what's called Secure DNS. So essentially, any Mac, Windows, or Linux computer with my TwinGate client installed, this policy forces them to use DOH. I can actually enforce that and make sure this is happening. I can choose which DOH server I want to use. So I can use Cloudflare, Google, OpenDNS, NextDNS. All these are public DNS servers, DNS recursive resolvers that support DOH. Now, if I have some restrictions on what DNS servers my company can use, I can specify a custom DNS server here. And this is pretty cool. With client configuration, I can add this machine key to my clients, and I can deploy this with any kind of NDM solution I have. And as long as the machine key is on their computer, it doesn't matter if the TwinGate connection is open and connected to my network. It'll still make sure they're using DOH. Make sure the DNS queries are always encrypted and secure. It's persistent. Now, you also got fallback. In case something loses connection, whatever that might be, you can say, you know what, just fall back to the system's DNS. Maybe you got your DNS server handed to you from your ISP, and it's actually their DNS providers. You don't want to do that. Then they're really seeing what you're doing. So in that case, you might want to go, hey, you know, I want to be pretty strict. Require DOH, even when resolvers fail. And the resolvers will be the DNS servers themselves. Hey, network chuck in the future here. TwinGate just gave me DNS filter. They unlock it for me. Thank you, TwinGate. I'm going to enable it for everyone. Okay, now let's edit our filtering profile. Allow list, deny list, security categories. It's already blocking threat intelligence feeds, content restrictions. Oh yeah, Mike has a gambling problem. Alex is always on Facebook. We'll leave YouTube on. Privacy protection. We can block ads and trackers. Done. This is pretty cool. Thank you, TwinGate. I just turned it on and we already have so much in there. It's all from Nick. Florida Nick, and Austin's MacBook. I'm actually really excited about this. It's already doing stuff! If you're not already using TwinGate, you need to use it. Check it out, link below. I'm a massive fan of it, and I've got a video up here somewhere where security, or DNS over TLS, transport layer security, will be more popular than DNS. Now back to DNS security, DOH is not the only option, even though it is one of the more popular ones. We've got DOT, or DNS over TLS, transport layer security, which also is secure and encrypted. We've got DNS crypt, doing a lot of the same things. DNSSEC, which is actually a suite of tools on how to make sure every query and response is valid, not just encrypted. And then you have DNS servers like Quad9 that do advanced things. Like when you use them as your DNS server, they could do malware prevention. If you happen to be going to a website or URL that's bad, known bad, they can prevent you from doing that. Now, DNS is more than just domain names to IP address mapping. Check this out. So looking back at our zone file for networkchuck.com, there's a lot of stuff going on. Some things you're familiar with, others were like, what? So for example, right here, we have what's called A records. These are our domain names to IP address mappings. Probably the most popular one you're aware of. Another one that we just saw as we were looking at our life of a query going through that process was a name server, otherwise known as an NS record. The NS record or name server record tells us what server, what authoritative DNS server is responsible for a second level domain. So networkchuck.com, this is his name server, or at least one of them. If you scroll down just a little bit more, you'll see this crazy thing. Quadruple A records, overpowered. All it is a domain name mapping to an IPv6 address. I'm not going to cover IPv6 in this video here. Just know it's bigger and more than IPv4 addresses, but they have the same function. And if we scroll down a bit more, we're getting to some more exciting things. This is kind of crazy. We have what's called MX records, or mail exchanger records. These records identify what servers for a domain handle email. What does that mean? Well, it means if you were to send an email to me, which my email address is chuck@networkchuck.com. Let's draw it up here real quick. And if you're interested in sponsoring one of my videos, it'll be sponsor@networkchuck.com. When you type in this email address into your email client and you click send, your email server has to figure out who manages the emails for networkchuck.com. Which server does that? So here is just a demo record. You might see mail.networkchuck.com. In reality, I use Gmail or Google Workspace, and it would reply with a bunch of Google servers that handle my email. Then we have a fun one down here. PTR records, or pointer records, how I like to refer to them. These are for reverse DNS. Very important for security. These allow you to take an IP address and go, boom, which domain name belongs to this IP address? You're like doing DNS in reverse. So this allows you to verify that when you have just the IP address, that's a great situation. You don't have to query anything. It allows you to which domain name belongs to this IP address. You're doing DNS in reverse. So this allows you to verify that when you have just the IP address, that's a great situation. You don't have to query anything, but maybe it's not the right one. Maybe it's not secure. Let's verify that. So you can query a DNS server and say, do you have a pointer record for this PTR? And it will apply with the actual domain name it belongs to. It'll look crazy like this often, but that's what it's doing. Kind of a crazy concept. Now, C names are really fun. They stand for canonical name. Just kind of a fun word to say. And isn't that the company that runs Ubuntu? Canonical? Yes, it is. Canonical. Can I spell this first time? I think I did. This allows you to create an alias for a domain. So for example, shop.networkchuck.com or even www.networkchuck.com and point it to another domain, a canonical domain, which means true, a real one. So alias to real. So just think when you want to point a domain name to a domain name, it's usually going to be a C name. And yes, when you want to go to www.whateverwebsite.com, that's going to be a C name record pointing to the real domain name. And finally, one more record we'll talk about. This is not exhaustive because DNS is the whole thing. Even though we've covered a lot so far. Like you are going to know DNS by the end of this video. I mean, you already are there. Last thing we're going to talk about is TXT records, which just stand for text records. These back in the day were made just to kind of share messages with admins. I don't know, could they leave notes when they would do DNS requests? Sounds kind of fun. Tell you what, I'm going to leave a secret message for you guys. You can query this. It's going to be secretmessage.networkchuck.com. Query that using your favorite DNS querying tool and see what it says. And please comment that below. That's your homework. Now, text records are used for a lot more than just plain email. In fact, they're vital in how we secure email now. Yes, we're back to email. Like for example, this one right here is an SPF record, or a TXT record specifying an SPF server. This TXT record defines which servers are legit for a domain. So for example, this one might say only mail from mail.networkchuck.com is valid for our domain. If it comes from anywhere else, any fishy area, that's not it. Deny it, reject it, you don't want this. And other mail servers can query these TXT records to see that list of verified mail servers. You also might see DKIM TXT records to verify that emails weren't messed with in transit, or DMARC, which is a fairly new thing. We actually have a course on DMARC on academy.networkchuck.com. And this is all about configuring policies on how to deal with mail that doesn't pass DKIM or SPF, and how a domain will utilize SPF and DKIM. Telling you DNS is extremely powerful. Now for you, if you want to get your own domain, this is not sponsored by any kind of domain provider. Let's say you want to buy ilovecoffee.coffee. How does that process work, and how do all the DNS servers we talk about find out about you? Well, it starts with going to a domain registrar. It's kind of fun to say. Go ahead and say it for me real quick. Say it out loud. I can hear you. Squarespace is one of those main domain registrars now because they bought Google domains. Now, there's actually one boss I didn't talk about that's above the mafia bosses. This organization has ultimate authority. They're called ICANN because they can do whatever they want. They're the Internet Corporation for Assigned Names and Numbers. It's a mouthful. I really don't want to write this. I'm going to do it anyway. These guys help govern DNS, making sure it runs smoothly. They're actually the ones who can validate who can become a TLD server. Another main role they have is they accredit domain registrars. Meaning they sign off on these guys. They're legit. You can buy a domain from them. We speak. It is Squarespace for $50. No one steal it. Once I buy it, I then have a choice. I can actually use Squarespace as my name server. So my authoritative name server for my domain, which means they would hold my zone file. DNS servers would ask them for any information about my domain. Now, if I didn't want to do that, this is a common thing. Let's say I want to use Cloudflare as a name server, because Cloudflare has a bunch of cool features to protect your websites and assets. So I might say, you know what, Squarespace, you're cool as a domain registrar. I love you for it. I don't want to use you as a name server, so here are the name servers I want to use. So you tell Squarespace that. So I'm going to be Pablo. Pablo, I trust this man with my life. This is the guy I'm going to tell everything about me. You can ask him, he knows. So Squarespace, now armed with the knowledge of your name servers, has a duty of updating the TLD registry, the top-level domain registry, with these name server records, or NS records. Now I'm curious, who operates .coffee? I've got to find out. I'm going to query for an NS record for coffee.
A man learns his command using the man command bits. Man, what the fuck? NS lookup. Okay, then query names of interaction. Okay. Why the fuck would I need this? No, not this. DNS resolution. Identity access management. IAM.
I'll ask one of the root servers. I'll ask Jay again, I trust him. Okay, so v010.nick.coffee. That's interesting. Who is that? That's a great segue into who is. When you register a domain, you actually kind of register a lot of stuff about you as the owner of that domain. The name, company, address, and that information is maintained in the who is database. I'm going to discover who this vic.coffee is. So I looked it up and check it out. I can't see it, because you can also pay your DNS registrar when you register to make your information private. It's an extra fee. But I can see that it says Identity Digital Inc. I don't know if that's real or not, because everything's redacted. But if I search for google.com, or let's do CIA.gov. Everything's redacted. Let's try someone real. Facebook. Okay, cool, we got some stuff for Facebook. There it all is. So I don't know who nick.coffee is, but Squarespace would have to tell them if I bought ilovecoffee.coffee. Now, two more things I want to talk about at the risk of making this video way too long. I don't care. It's my video. If you're still here, thank you so much. You're awesome. Let's take a little sip of coffee together. First thing is you can actually run your own DNS server inside Cypress. It'll be a recursive DNS server, similar to a public Google server, where it'll have a cache of A records, domain names to IP addresses that it's remembered that you've been to before. And if it doesn't know an IP address, it'll be configured to go to an upstream DNS server. So for example, right now I've got a Raspberry Pi. And my server is running as my local DNS server for my studio. It's running what's called AdGuard, which is fantastic because it can block ads. But when it doesn't know about the website, it'll just ask the upstream server, which I've configured as Quad9, Cloudflare, Google. I've got a few actually. Another popular one is Pi-hole.
Bro, what I want to learn is DNS resolution.
Hints file. This is a file, a text file stored on the server, on the DNS server, and you can go out on the internet and download this file for yourself. I did. That's how you got some screenshot. This is a file, a text file stored on the server, on the DNS server, and you can go out on the internet and download this file for yourself. I did. That's how I got this awesome screenshot. This file tells us where are the root servers that we need to talk to. What are the IP addresses? So we've got a.rootservers.net, here's the IP address, b.rootservers.net, here's the IP address, and we have IPv4 and IPv6 addresses for those. C, D, E, F, G. They didn't all fit on the screen, so you know that they exist. They're also there. So now that we have the IP addresses of those root DNS servers, remember this is the DNS server doing this job, the DNS server that our computer talked to ask for this. The DNS server is now resolving, it knows where the root servers are, so now it's going to ask the root name servers, can you tell me where the top level domain servers are for .NET? Because remember, we're resolving www.schetzler.net. So we need to find, we start at the top, start at the root, next level down is the top level domain .NET. So where are the top level domain servers for .NET? The root server knows, or the root servers know. All of those root servers know. So the DNS server asks the root name servers, and the root name servers say, okay, I'll check my root zone file. The root zone file has a list of all of the top level domains. So the root DNS server is going to look in that root zone file and find the section that is .NET. There's a section for .com, there's a section for .aws, there's a section for .ninja or unicorn or whatever top level domains exist. And in that file, it says, okay, .NET, these ones are located at a.gtldservers.net, b.gtldservers.net, c, d, e, f, g. These are different from the root files because it's not rootservers.net. This is gtldservers.net. These are new ones. Also in that root zone file is what these mean, because you wouldn't want to tell the server you need to resolve this to resolve this. So we give it a.gtldservers.net, and we also tell it, okay, they're here 192.5.6.30, 192.33.14.30, etc., etc., etc. The whole list there, that list comes back to our name server, and the name server now knows. The root server responds, and it says the .NET top-level domain servers are, here's their IP addresses, here's where you can look, here's who you ask next.
Just
So
like in
now,
how
the DNS server talks to the .NET top-level domain DNS servers. We have more DNS servers, so many DNS servers responsible for making this work. And the DNS server, our DNS server, talks to the .NET top-level domain DNS server, and it says, can you tell me where the name servers are for Schetzler.net? Who's in charge of Schetzler.net? And when you pay to register a domain, this is what you're paying for. You are paying the .NET top-level domain DNS server to record who's in charge of your servers. So you say that. Who are the name servers in charge of Schetzler.net? The .NET TLD DNS server says, sure, it's pat.ns.cloudflare.com and cache.ns.cloudflare.com. And if we need to, we can go through the whole DNS resolution process to resolve these ones. But we're not going to talk about that. We're just going to assume we already know where pat.ns.cloudflare.com and cache.ns.cloudflare.com are. Those are stored in our DNS cache because we've looked them up before. So where are those? We know where those are, so let's go ask those now. We know the name servers for Schetzler.net. We need www still. So we ask the Schetzler.net name servers for the A record for www.schetzler.net. And the A record for www.schetzler.net is there listed on the Cloudflare name servers. And the Cloudflare name server can say, sure, it's 185.199.111.153. There's your IP address. And so now our DNS server knows the IP address, and it can respond, and it passes that along back to us. That's the process. We have all sorts of DNS servers involved. We got the root, we got the top level domain, we got the name servers, we got whatever DNS server our computer asked. Lots of DNS servers needed to make this process work. It's a complicated thing, but it's the system that makes the entire internet work. And now you can see why, when the DNS server gets a response and gets this IP address, it's likely to cache that and store it for a while, because it doesn't want to go through that process. Record that stays in the cache longer, which means that the next time someone asks, it's likely to be there in the cache and not need to go through that full resolution process again, which saves the DNS server some time, because each of those is a message being sent somewhere in the world that takes some amount of time. So that was our full resolution process. Now we have other DNS servers that aren't full resolvers. They don't do the full resolution thing. They are called forwarders. Perhaps your router is a forwarder and does this process, or perhaps your internet service provider, or perhaps you've set up a Pi-hole. The Pi-hole does exactly this and does this forwarding process. What's the forwarding process? Well, it starts out the same. Your computer doesn't know whether the DNS server it's talking to is a forwarder or doing that full resolution. Your computer's just going to reach out just like it did before and ask what the IP address is. The DNS forwarder is, again, not actually saying this, but it's going to go find out. So now the DNS forwarder, what does it do? First thing it does is it asks a resolver. So it just asks someone else to do this process for it. What's the IP address? The DNS server, the DNS resolver that's going through that full process is going to find that out, and it goes through that exact full resolution process that we just talked about, talking to the root, talking to the top level domain, talking to the name servers, and finally getting those correct records. And finally, once it goes through all that, it responds, it turns that A record back over, and it says, here, DNS forwarder, here's the A record for the thing that you asked for, here we go. And once it has that, it turns it back over to the DNS forwarder, and what does the DNS forwarder do? It just turns it over to your computer, just like the DNS full resolver did. It turns that record back over to your computer, so now your computer has the A record, and it can do the things that it wants to do. So you may be wondering at this point, what's the point of DNS forwarding? Why does it exist if all it does is forward on to another DNS resolver? Because it still has to go through the full resolution process. What is that doing for us? Well, it takes a little bit of work to run a full resolver, so we have these much simpler systems to set up, the DNS forwarders, and what benefit do they provide? They provide the benefit of being closer to you. So you can have a DNS forwarder running in your house, like I said, Pi-hole does it, your router might do it, your ISP might do it, and they're very close to you. And all that does is give you a cache that's closer to you that saves you time in the future, because, again, we're limited by the speed of light and distance matters, and if you're sending those requests all over the world, then it takes time for those things to be resolved. So we can put that cache in your house even, to have that closer to you if you need it, and it's simpler to run the forwarder than it is to run a full resolver, although it's also not super complicated to run a full resolver, should you so desire. It just takes, intent. You have to want to do it. And that's the DNS resolution process. That's what every single DNS message goes through, as long as it's not already in the cache. If it's in the cache, obviously the server's just going to return it from the cache, but if it's not in the cache, then it has to go through that full resolution process somewhere along the line. So before we go, check yourself. How does the DNS resolver do its job? And if you know that, then you understand the DNS resolution process. DNS name resolution. DNS name
The fuck?
DNS name resolution. What does it take to turn that awesome name www?
I like this guy, so I'm gonna watch this guy.
Want.
Not this one, this one. So wait, I'm gonna watch that guy. Just watch that video. I just watched that video, and he just highlighted that I need to know this to get started, to become learn or become a cloud engineer. So I gotta learn this after getting that. I'm not kidding, bro. DNS yeah. How the fuck do you write hierarchy, bro? Hierarchy. Okay. IP addresses, bro. What the fuck is SolarWind doing? AI. Admin dashboards or something. What the fuck is this? DNS is a hierarchical and decentralized naming system for computers, services, or other resources connected to the internet or a private network. It translate human readable domain names into IP addresses, make it easier for user to access website and services. The DNS hierarchy is organized as tree in reverse order. Tree up, down, bitch. Okay, one to many. At the top of the root domain, followed by top level domain TLDS domain, top level domain name, second level domain names like networksuck.com, and second domain is networksuck. Okay, the structure ensures that the guy after second dot from the behind. let's say that like that. The structure ensures. Is this recording? Okay. All right. DNS hierarchy organized as a triad in reverse. I know. The structure ensure efficient, scalable domain name. The structure resolution. What the fuck does that mean, bro? Domain name. Okay, DNS. This is what I want to go. Okay, domain is a fundamental part of internet infrastructure and take a role similar to that of the phone book, just as you wouldn't want to remember a long strip of number off the top of your head to call a friend. DNS ensure that you don't have to recall complicated numerical IP addresses to visit your favorite websites. DNS will quickly translate user-friendly domain name into numerical IP addresses that computer use to identify each other on the network. When you enter a web address in your browser, the DNS spring into action. It will find the corresponding IP addresses, enabling your device to quickly and seamlessly connect to the desired website. I know that much, bitch. The system simplifies. What the fuck is that? Um, grandfather, sorry about that. System simplify navigating the internet, allowing us to use making the internet more accessible and easier to use without the DNS. Everyone will have to memorize and type long strip of what is DNS resolution. DNS resolution or DNS lookup. What the fuck is DNS lookup? Page was not found. Okay, is the process of converting a domain name such as www.example or host into a machine readable IP address such as okay, that's it. IP address. The DNS process involves querying a series of DNS servers to find and return the correct IP address. This process ensures that when you enter a web address, your browser can connect to the intended website email. This it is what I know, but I don't know in depth like what is the hierarchy of the DNS, bro. Okay, I'm gonna look at that. The process ensures that when you enter a web address, your browser can connect to the intended website, email, or online resources. The domain names are resolutions process start with the root name servers and continue to the top level domain servers before finally reaching the authoritative name. Okay, then government visit despite the many said DNS resolution is a fast process with the average milliseconds. However, network issue overload the DNS and other problem millions the DNS resolution time. So is all the part, bro. So okay, bro, this gonna take time, bro. I need to learn this. So my oh, can I learn this? All of this in a night? Oh wait, what time it is? It's 8:11. So can I do that? So we gotta figure it out, bitch. So I can't understand. I understand what it does, but I don't know how many stops it makes and where the stop it makes. Like I know it makes a stop to the router to the DNS servers, and then asks a server. I know it talks to DNS to the root server or something, and then it exactly what the fuck is my accent with exactly or something. Uh, so it knows what the where the IP address could be found, so it gives to that. I only know this cartoonist or vague response in that, but I don't know what it actually makes stop in between. So like I don't know what the fuck is a root name server. I think that's like .com, .net, like different stuff. Like .com is one root server, and I think it's like that. And what is TLD servers? What the fuck is TLD, bitch? T top level domain servers as in the hierarchy of okay. Wait, I need to eat dinner. Sorry about this. I'm pausing a lot today, and um, I'm like addicted to nicotine, so like I'm going out and in from the house, so to fulfill the quota after day. What's up, bitches? Let's get started. My goal is to finish all of this today, and if I got time or any energy left, I'm gonna do this. Networking deep dive. Okay. Sorry about that. Okay, Git is here. Okay, networking DNS resolution. I need to know where the fuck does the DNS goes to, bruh. I need this. I need this. Involve process services. Okay. So the DNS server is recursive in nature, brother. That's what I understood from that guy, Network Chunk or something. Recursive resolver, intermediate that receive DNS queries from end users, user devices, and perform the necessary lookups to resolve a domain name into an IP address. And these resolvers are an essential part of the DNS infrastructure as they handle the complex tasks of querying multiple DNS servers on behalf of the user to retrieve the correct IP addresses after receiving a DNS query or resolver. A recursive resolver will check its own cache to see whether the domain name request by the user has been resolved. If so, the resolver will immediately return the IP address, speeding up the process, reducing the load on the border DNS network, and ultimately improving efficiency. Because of resolvers are there, catching mechanism are particularly beneficial for frequently visiting websites. Then root name servers. Root name servers are the first step in DNS processes. When a recursive resolver intimidates a query to resolve a domain name, it will first reach out to the root name servers. While root name servers do not hold specific information and individual domain names, they do have critical directory of information about TLD. What the fuck's TLD? Okay, top level domain name. Fucking hell. Root name top level. What the fuck is root name servers? What is root name? Manage the DNA as information. And provide one piece of the puzzle that contains the actual DNS record authoritative name server. Okay, tls.com, and then authoritative. Okay, first the root. The first step where our recursive resolver initiate or query to resolve or domain name. It will first reach out to the root name server. While root name server do not hold specific information about individual domain names, they do not have a critical directory about information. They analyze the incoming domain name extension and direct query to the appropriate TLD name server for further query. Okay, I think that's all I want to read in this for right now. And TCP transfer protocol and internet protocol. Okay. I need a video for that. YouTube.com, bro. Who the fuck is he? Okay, and then what the fuck was I even talking about? TCP/IP I know about this in a nutshell, but I don't know what's going on inside it. PROTOCL protocol or something. Bruh, both are the same thing. TCP really work. Three-way handshake. I know three-way handshake, by the way.
That you know the TCP/IP model for the real world, you'll often hear network engineers saying there's a problem at layer 1, or perhaps there's an issue at layer 3, or there's a problem at layer 7.
Maybe he's a gear guy. Yeah, oh my god, fucking hell.
This is episode 3 of my free CCNA course. And a huge shout out to Boson Software, the official sponsor of this CCNA course. They are the reason this can be made available for free, so I highly encourage you to go check them out. They have the absolute best CCNA, CCNP, labs, and practice exams. Okay, I need you to stop and think about this for a second. I want you to appreciate the fact that this device right here, a Raspberry Pi, can connect to a network and talk to my iPhone. They can share photos, they can email each other, do whatever. It might not seem amazing because this kind of stuff is just commonplace, what we're used to every day. But once upon a time, a long time ago in a galaxy far, far away, if you had a device that was made by 2 different companies, they could not talk. This is where things like the TCP/IP model or the OSI model, networking models, save the day for real. But how? Let's take a look back in history real quick. A long time ago, I'm talking Stone Age, 1960s. Some smart guys sitting around the computers and they're thinking, man, gee willikers, I really wish they could talk to each other. I would just share your file with your friend, but they couldn't. But then they hatched an idea, they came up with something. They go, what if we can network these things together? What if we can connect our computers together and we can send data across? They did that. 1969, the birth of the first network, we call this, or they call this, ARPANET. The US DoD, the Department of Defense, came up with it. And it was revolutionary. Like, people can actually have their computers talk to each other, which I know it sounds like not a big deal right now, but back then, that was it. That was the new thing. But hold on, here's the problem. This was more of an idea. Like, they legit did it. Like, here's the first network diagram my computer ever was. Check this out. Look at that thing. I have no idea what's happening.
Bro, why is the hardware here? PDP, PLI, please note that while this maps shows the most population of the network according to the best information obtained, no claim can be made for its accuracy. Okay.
And when I say idea, they're like, yeah, this is a cool thing we can do. They actually invented what's called packet switching, which is what we do today. But what they didn't have yet is the how. How do we make computers talk to each other? You see, that wasn't quite ironed out. But the idea spread like wildfire. So companies like IBM, they were like, heck yeah, we have computers. Let's design our own network. And they did. It was proprietary, meaning it only worked with their stuff, which is fine if you have an IBM computer, but there wasn't just IBM. There were other companies, and guess what these other companies did? They also designed their own networks. Now, so let me step back. When I say design, I mean they invented their own networks. They came up with the idea of how to actually connect computers together. And because these networks were proprietary, they couldn't really play well with others, meaning these networks could not communicate. Couldn't have this device talk with this device. They were basically speaking different languages. This network over here is like bonjour, and this network over here is like, what? No idea. Now, one time this is some primitive stuff. I'm talking about this is before Ethernet cables were invented. Like, we're so used to Ethernet cables. We're so used to the Ethernet ports. These weren't a thing. Each of these companies had different versions of whatever they called theirs. Like, you ever try to charge your iPhone with an Android charging cable? It doesn't work. It's not compatible. That was the networks of yesteryear, or a long time ago. Now, eventually they realized, hey, this is kind of stupid. Maybe we should all use the same networking stuff. Yeah, let's do that. No, easier said than done. This involved meetings and committees, and I want to do this, I want to do that. You're wrong, sir. A lot of that kind of stuff. Now, there's a long and maybe interesting history, if you're into that, of how this all came about. But we eventually ended up with a networking model. A model that defines how we can connect our stuff. So that when IBM makes a computer, when Apple makes a computer, when Microsoft makes a computer, we're all putting the same technology inside the computer to make it talk to the other computers. That's why it's such a beautiful thing that a Microsoft computer can send a photo.
Bro, his lip sync are not working, bro. Wait, I need to reload this then.
This is episode 3 of my free. Sounds like not a big deal, right? This all came about, but we eventually ended up with a networking model. A model that defines how we can connect our stuff. So that when IBM makes a computer, when Apple makes a computer, when Microsoft makes a computer, we're all putting the same technology inside that computer to make it talk to the other computers. That's such a beautiful thing that a Microsoft computer can send a photo to an computer, when Apple makes a computer, when Microsoft makes a computer, we're all putting the same technology inside the computer to make it talk to the other computers. That's such a beautiful thing that a Microsoft computer can send a photo to an Apple computer. We're all using the same networking technology. We're using the same networking standards. Now, actually, honestly, we ended up with two models. One that we actually use, and then one that we still cling on to and talk about all the time. I'll show you. The model we use today is called TCP/IP. This is what every computer supports and has implemented into their system. The TCP/IP model, and they also call it the TCP/IP stack. Now the other model, he wanted to be the one that won so badly. People were on his side, they were campaigning, but he just did not win. TCP/IP won for a variety of reasons, but it's just more widely adopted. So then why am I still talking about him if TCP/IP won? I'll show you. It's weird. Now again, TCP/IP is just a list of rules or guidelines, standards on how computers can communicate, how we design those systems. And there's a lot that goes into that. So to make things more simple, more digestible, easier to understand and implement, we divided all those functions into layers. Layers like this right here. Each of these layers defines some kind of protocol or standard we'll use when computers connect. So for example, the physical layer, we know it's going to involve Ethernet cables. The network layer, all about IP addresses and routers. So with this standard, we all agree we're going to use IP addresses when we communicate over the internet. Before that standard, that wasn't really the rule. You could have done anything. You could have used names from Star Wars or something. I don't know. Transport, we got TCP, UDP, port numbers. We'll talk more about that later. And then application, like, hey, when I open up my web browser and I go to Netflix.com, what protocol am I going to use? Do we all agree to use the same protocol? We all agree to use the same stuff, and it's beautiful. Now we can all talk together. We can all network together. Now this is the traditional view of the TCP/IP model, the layers we see here. If you're studying for the CCNA, the 200-301, you might see the physical layer divided into two separate layers like this, which I happen to love. And if you watch my last two videos in the series, you're already familiar with the first three layers here. You've already seen an action going through a network. We got our physical, the Ethernet cables, the network card.
I got presentation layer 2, bro.
It's the electricity flying. That's our layer 1. And then we talked about our data link layer. This is where our MAC addresses come in. Our layer 2 addresses. How hosts on the same network can communicate. And the switch uses those layer 2 addresses, those MAC addresses to know. Physical, the Ethernet cables, the network cards, the electricity flying. That's our layer 1. And then we talked about our data link layer. This is where our MAC addresses come in. Our layer 2 addresses. How hosts on the same network can communicate. And the switch uses those layer 2 addresses, those MAC addresses, to know where to send information. And then of course we have our layer 3, our network layer. We know this to be IP addresses. We know that we assign our devices IP addresses, and this is how they communicate. This is how the router can know where to find people and route those packets to the right people. And then we have our other layers, and we will talk about those, but not right now. We'll get to it. Okay, now, what about the OSI model? Where does this guy come in? Well, let me show you. Similar to TCP/IP, he works on layers. In fact, he shares the same layers as the TCP/IP model. He just has a few extra. So physical data link and network transport. Yeah.
Nobody told me that walking would make me better at my job, but thanks to WhisperFlow, here we are. I learned that ChatGPT works best with detailed prompts.
Yeah, well, let's talk. That's the same. But then at the application layer, it's a bit different. We're going to add a couple more. We're going to add a session layer and a presentation layer. Let me scoot this guy up a bit. There we go. Now, as you're studying networking, as a network engineer, the main difference between the TCP/IP model and the OSI model are these two extra layers. Now, the concept of these layers, what they bring to the table, do not go away with the TCP/IP model. I'm saying it too much. All that happened is we stuffed those two layers inside the application layer. But Chuck, you still haven't told us why we're talking about the OSI model. Why are we even talking about it? This is why. I told you these two models were at war with each other. Who was going to win? And during those wars, it was widely believed that the OSI model was going to be the one that was adopted, which by the way stands for Open Systems Interconnect. And because it was thought to be the clear winner, we started using the layers that the OSI model has as our day-to-day terminology. And even when TCP/IP was the clear winner and it killed and murdered OSI, we still refer to the OSI layers when we describe network functions. Now again, I can feel because layer 1, 2, 3, and 4 are as distinct and same as the TCP/IP model, as long as you're referring to the Cisco version of it right now. But when you get up to the layer 5, layer 6, and layer 7, clearly we got a little disconnect there. But when network engineers talk about it, OSI always wins. We will always refer to the application layer as layer 7. This right here is layer 7, and there's only 5 layers here. This is how we do it. It's how we roll. But I will say this. If you're trying to learn networking, if you're studying for the CCNA, you need to know both of these models. And there's a fun way to memorize this. So the OSI model, 7 layers, hard to memorize. Using the mnemonic device. So application, presentation, session, transport, network, data link, physical. Let's try all people
seem to need data processing. I'm sure there are better ones. That's just how I learned it. Let me know below if you have a better one. I can't tell you the many times throughout my career I referred to that phrase, that mnemonic device, to remember the 7 layers.
Bro, I can't remember it, bro. But step by step. Physical, like the hardware and stuff. Data link, links to the fucking, data link. Like, this is the protocol and stuff, bro. What the fuck, man? Protocol. Mix tiny packages and network. Build connection. And then build connection. And then 3. And then after that, transfer, yeah.
Processing. I'm sure there are better ones. What if you're not going from application to physical? What if you're going from physical to application? Which can happen routinely, right? I got one for that too. Please do not throw sausage, pizza, we reference to application. Okay, time to see what you learned. Get your coffee ready, your thinking cap on. Let's do this. Exam question right now. Question number 1. Which of the following operates primarily at layer 2 of the OSI?
OSI, data link, switch, build connection, network, hub, network. A WAP? What the fuck is a WAP?
Model. Select the best answer. And go. If you said the answer was switch, you're absolutely right. If I hit show answer, fingers crossed, yes, I'm right. The switch operates at the data link layer, layer 2 of the OSI model. Router? Nuh-uh. Where's the router operator?
Network.
Layer 3, IP addresses, the network layer. The hub?
Okay.
That might have been a little bit confusing for you because we compared switches and hubs in one of our earlier videos in the series. Where do they operate? Remember, hubs are stupid. They got no smarts. They don't operate at layer 2, they're not even aware of MAC addresses. All they do is just repeat electrical signals when they receive them. Out all ports. So they are primarily physical. And quiz, what layer is physical? Layer 1, right? And then a WAP, a wireless access point. This was kind of a tricky one because they do operate at layer 2. They also operate at layer 1. So they're not primarily focused on layer 2. So if you put that answer, you're half right. You're kind of right. But we're looking for what primarily operates at layer 2. And that, of course, is a switch. Question number 2. Which of the following devices operate primarily at the physical layer of the OSI model?
Physical, repeaters, routers, switches, bridges. So it's not bridges, it's not routers and switches. Then it's repeater or hubs. Physical, repeaters, bridges, hubs.
Select 2 choices. Now we kind of already covered this. Let's see what you got. Go. Okay, here we go. Here are the answers. A, repeaters, and C, hubs. Let's see if I got it right. Boom. Now this may have been a bit tricky for you because we haven't talked about bridges, and that's fine. But through the process of elimination, you know that, hey, switches, those are layer 2, and we just talked about that. Routers, layer 3, of course. We just said that hubs are physical, and I even mentioned that hubs will repeat.
I want to know what TCP IP protocol, bro. Not OSI. I already studied that in school, bro. Okay. Cross that stuff, networking basics, TCP IP protocols. But what the fuck is happening to this?
Electrical signals when they receive.
Okay. 1 million views. This is probably Indian, bro. I can tell 1 million views. Free program does it, bro, but If he's not Indian, I'm gonna watch it. Okay. Why is the fucking shark in it? David Bomol. I probably.
Hi everyone, today we will learn TCP/IP protocol suite. So let us start.
Fuck you, Indian bitch.
I'll say this, Chris. I mean, in the CCNA, as an example, they teach a little bit about TCP. It doesn't go deep as perhaps we'd like for the real world. So I'm really looking forward
I thought it was 30 minutes.
to you showing us how this actually works in the real world.
Alright, I'm gonna watch it like into 2x.
Good Bumble back with Chris. Had a lot of great feedback from our previous videos. Chris, welcome.
Hey, it's great to be back here with you, Dave. Thank you for having me back.
Yeah, so what are you going to show us today? Because I'm quite excited about it.
So we encourage everybody to do that.
That's great. So you take away, Chris. Show us.
So we encourage everybody to do that.
That's great. So you take away, Chris. Show us your trace file, and let's start with the beginnings of TCP.
So I think this is a great place to start, David, because how many of us... okay, let's go from the networking background, right? You come from the networking background, I do as well. How often were you blamed for network problems?
It's always your fault. Come on.
Right? It's slow. It's the network. Oh, it's that not connecting properly. It's the network. It's the network. I think it's kind of funny because sometimes we'll even make a phone call to our bank, or we're setting up a flight, or pre-pandemic, or whatever it was, and you're on the phone and there's like this hold, and the poor operator's saying, "I'm sorry, my network's slow today."
Exactly.
Have you ever had that experience?
Yeah, exactly. It's you guilty until proven otherwise.
Absolutely. So right there. If we're in the network space, or even if we're just growing in our knowledge of protocols, TCP should be a big part of that. And the reason why I took that down, it's not the network conversation, is because being a consultant, being a troubleshooter, that's what I do. A lot of times people call me because they're having network issues, or it's the network people and they're calling me and they're saying, "Hey, I'm getting blamed for this, so what's going on?" But then I look at the trace file and I start with the transport layer. Why? Because I can then take the OSI model and I can break it in half. If I start looking at TCP, and TCP looks healthy, I don't see delays, I don't see any weird TCP indicators at that layer, well then I can go up and I can take a look at the application. But if TCP is not healthy, if I see retransmissions, out of orders, window problems, blah, 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 those kinds of things, or especially with retransmissions, okay, now I can go down to the network. Why is the network dropping traffic? Why are things not being passed properly? What kind of hiccups are we having in getting data through? So that's why, David, we're going to start here at the transport layer specifically with TCP. This is why it's such an important thing to understand for troubleshooters, for network analysts, even cybersecurity professionals.
I'll say this, Chris. I mean, in the CCNA, as an example, they teach a little bit about TCP. It doesn't go deep as perhaps we'd like for the real world. So I'm really looking forward to you showing us how this actually works in the real world, and I want to quiz you on like all these different flags and things. So yeah, looking forward to it.
Fantastic. Okay, so good. So let me ask you this, David. When it comes to the TCP handshake, is that something that you would be quizzed about on your CCNA?
Yes. So yeah, I hope you're going to explain the three-way handshake in proper detail with a proper Wireshark capture.
Absolutely. So let's do it. So here I've got a trace file open, and we're just going to spend some time on the handshake.
Wait, this is 1 hour long and my fucking internet is way too slow, and because of this laptop I think, so like I gotta download it and watch it for an hour. Customization with no, bro. That looks sexy, by the way. But I'm still happy with this stuff. What I want is that Arch Linux vibe. I'm not gonna lie to you, bro. Wait. Can I use in Hyperland? Okay, I'm not even gonna do that. What the fuck was I even talking about? DB Hyperland. Dixie Hyperland. Introduction to Hyperland. Grok. His like Hyperland and Genome, the same thing, like I know. But like they are different, but like they're the same. Okay, I think that's downloaded. Wait for a second. Switching to Hyperland, Debian user Hyperland. Install scripting from Debian. Install Debian Pixie plus Hyperland. Not ready. Hyperland rejected. Demand root stability. What the fuck is this? Why the fuck is the creator not using Debian, bro? I'm like a fucking Linux.
I'll start with something non-controversial.
No, I'm fine with controversial. That's not usually my problem. Yeah.
It's well known around these parts that in 2007 you did an interview where you said that although you've used many Linux distributions, you had never used Debian because you found it difficult to install.
Yeah.
What the fuck? It was the most easy, bro. What the fuck, Fedora? See, they saw similar high-performance layer both manage desktop window and overall Linux graphical experience, but they do it very different ways. You know, is a full desktop environment with a tilting window manager plus compositor. They mainly focus on arranging managing windows in a smart keyboard driven way, automatically tile without overlapping much. You can switch layout resize. This is what I want to make, bro. I'm not kidding, but I want to learn fucking Hyperland once in my life.
Is imminent.
What the fuck is his desktop, bro?
Welcome back to the channel. Debian 13 is imminent. The freeze has just happened, and the release is very likely to land this summer. What's exciting? For the first time in its history, Debian Stable will ship with some of the latest desktop environments. It will include GNOME 46 and yes, KDE Plasma 6.3. This is a historic shift for Debian, which has always been known for its conservative, rock-solid choices. But that's not all. Debian 13 will also introduce apt3, a new deb package format, and official support for RISC-V. All of this makes it arguably one of the most succulent and feature-packed Debian releases ever. However, one piece of news might disappoint some users. The Hyperland window manager
Building my own DE, it didn't take more time. Build one wheel. Bro, who used it, Dave? Interesting, bro. Get some balls, bro. I'm not kidding, bro.
Have you tried it since?
No. That was quick. I'm sure it's gotten much easier to install. To me, a distribution is, I'm sorry.
What the fuck is this?
You may want to close your ears now. A distribution is not very interesting. I want it to be easy to install so that I can just get on with my life, right? Which is mostly the kernel.
Bro, I wanted to watch that, say. Okay, sorry about this break, type of thing. Where do I fucking learn Hyperland, bitch? This is the shit I want to build, bro. I'm not even kidding, bro. I'm not.
I'll start with something non-controversial.
No, I'm
optimized by desktop.
Years now. A distribution is not very interesting. I want it to be easy to install so that I can just get on with my life, right? Which is mostly the kernel. The closest I got to installing Debian was one machine. I forget which one it was. It may have been and eventually I figured out what was the problem with that machine, but by then it was too late.
If there's a way to break installing an operating system, I found it multiple times, and if there isn't one you already know if I found it, and Debian last time, super easy. Highly recommended trying.
Maybe I should try. I mean, one of the problems I have is I am not an MIS person. I mean, I may do kernels and full thing. That means that I'm technical, but when it comes to actually maintaining machines, I am a complete disaster. I change my own machines regularly, so the system on my machine would be easy, right? I end up upgrading usually, but I end up having also to maintain my family's machines, and that ends up being the one that I don't upgrade my family's machines very often, and I don't want to run multiple different distributions across different.
Look at this stuff, bro. I'm not even kidding. The fuck is this, bro? Dang, bitch. Bro, look at this, bitch. Bro, people are flexing shit in their fucking YouTube videos, bro. Flexing stuff. But this shit is really, really cool, bitch. Look at this one, bruh. Look at this, look at this, look at this, look at this. When you open that, bro. Dang, 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 bro, what the fuck? Wait the fuck up, can I? can I use it together, like genome beams and hyperland for its own stuff? Can I do that? In Debian, I want to write in Debian. Okay. I need to learn how to use Hyperland for a second. Okay. So let's do this stuff. What the fuck is that? Okay, never deep dive. Alright.
I'll say this, Chris. I mean, in the CCNA, as an example, they teach a little bit about TCP. It doesn't go deep as perhaps we would like for the real world. So I'm really looking forward to you showing us how this actually works in the real world.
If I saw a new 4-tuple immediately, is that something that you would be quizzed about on your CCNA?
Yes. So I hope you're going to explain the three-way handshake in proper detail with a proper Wireshark capture.
Absolutely. So let's do it. So here I've got a trace file open, and we're just going to spend some time on the handshake. Only we're going to spend enough time to go into the detail to really understand what the handshake is doing. What's the purpose behind it? It's way more than SYN, SYN, ACK, ACK.
Because that's what most people know it for, yeah.
We passed that question on our CCNA. Good. SYN, SYN, ACK, ACK. Wonderful. Why is it called SYN? What's happening in that handshake? Really, why was that term selected? What is an ACK? What are we ACKing? Let's get to it. So if we take a look at this PCAP, and again, everybody go get it, go download it. And the one you're going to make sure that you're on is TCP Handshake, and I threw my name on there just so you knew that it was me. Here, this first packet that's going out, this is only a 15 packet trace file, right? So this is not a big one. This isn't just some long, huge TCP thread. And really the way that I captured this is I just opened up a browser and I went out to this website that's open. It's a website that's designed to be just over HTTP. I wanted to make sure this wasn't encrypted. It's just a very simple conversation over TCP. But what we're going to focus in on, let's go ahead and get into that handshake. I'm going to take a look at packet number 1. And this is just the first packet in the trace. This is the first time that this station reaches out and establishes or tries to establish a connection over TCP. Let's see what's going on in this packet. I'm going to go ahead and move my detail up a little bit, move my hex over just to see, head check to see if I have any clear text over here. Of course, in the SYN, I'm not going to see any data, but I just wanted to see what we have over there. I'm just going to move this back. Okay, so in my detail, I'm going to skip over layer 2, layer 3, which would be Ethernet, IP. I'm just going to go straight to layer 4. Now, first thing, I can see the client is sending, it's starting from this high number source port. We call this the client-side ephemeral port. Usually this is a pretty big number like you see here. Right away, when I just see that, I wouldn't even need to see this up here. Usually when I can see that information right here, I'm going to destination port 80, I'm coming from this high number port. Right there, I know that, okay, client is sitting on 54.846, the server's on 80. Port 80 is going to be a common number. It's going to be a well-known port number for that service. Okay, great. The next thing that Wireshark does for us is it gives us something called a stream index. What that means
Wireshark.
is
I will
basically
download
it's the
app and
for
go there.
tuple for this conversation. What's a for tuple? 2 IPs and 2 port numbers. That gives me a unique TCP conversation. So Wireshark says, hey, this is number 1, or in this case it starts at 0. But the first TCP stream that I see in this trace file, this is 0, and this is all just 1. If I saw a new for tuple immediately after this, let's just say, David, I saw 2 sins go out. Sin. Well, then I would see
Wireshark. DBIAN Debian. App image of that. I can download anything for anything distribution. But is there hours? What the fuck is the B? Learn Hyperline Debian. Okay, I'm gonna learn that in the background. Wireshark. There is, and then. Alright. I'm down the app image, bitch. Moving to.
stream 0 and then stream 1. Okay, moving down, let's go ahead and talk about this sequence number thing. Okay, so here's sequence number 0, relative sequence number. The reason why this is called a SYN is because in the handshake, I have to exchange, if you will, or synchronize the sequence numbers of the two sides. So this raw sequence number that you see here, this big, scary looking number, this is a very important number to TCP. All right, so when I send my SYN to you, David, I'm telling you, hey, I'm going to start counting the data in my direction from this number. It's called the ISN, initial sequence number.
Just randomly selected, yeah? Or how is it chosen?
Yeah, it is a somewhat random thing. There operating systems, at least historically, They'll typically start in a certain range. I mean, I can't spout that off the top of my head and go, hey, well, this must be a Mac system or something like that. But a lot of times you'll see them start in certain ranges. The idea here is it just has to be unique, right? And it's a number that's randomly generated. It's a high number. It's very unlikely I'm going to see this again on a different connection very near in the future, right? That number, I offer that to you. And then Wireshark just does me a solid. It just says, hey, let's just zero this number out, because we talked a bit about this in a previous video, how Wireshark goes, you know what, you humans have a hard time counting with big numbers. Why don't we go ahead and just zero this out for the purposes of this connection? So that's why we see sequence number 0, relative sequence number. Good with me so far?
Yeah, I wanted to ask you some questions. So let's start with the port numbers. So the source port is like a random port number, or ephemeral port goes by different names. I can't remember the ranges off the top of my head, but it's a high number, isn't it? And then like the greater than 1023 or 1024, depending on which operating system you're using. I think, Chris, that's the thing. I mean, you've got a lot of experience doing this in the real world. Different operating systems handle the port numbers, and like you said, the sequence numbers differently, don't they?
Yeah, they do. And really, when it comes down to it, something just when we're getting started with this, just to remember that as long as this isn't the same, right? So if I start a connection to you, David, I got to use 54846. If I want to start a new connection to you, well, then I can either increment it by 1. Depending on the operating system, it might be random. I could jump up to 55900 or something like that. But the point is, as long as it's unique, then when you are communicating data back to me, my machine knows what to do with it, right? That port now gives me a place to stick that data that the application can use. So there's something that happens in the handshake, and this is where we're going to start to deviate from the simplicity of SYN-SYN-ACK-ACK. This is what's actually going on under the hood. You notice my next sequence number is 1?
Yeah.
What this means is that Wireshark is telling me, this is a Wireshark value. Anytime you see these hard brackets here, that's Wireshark giving me information. This is not actually a part of the protocol itself. This is Wireshark doing me a solid. You see it up here, TCP segment length, stream index. The port numbers are a part of the protocol, so is the sequence number, but this is just extra info that Wireshark's helping me out with. But it says sequence number 1. So what happens when I send you a SYN, okay, you're going to be the server, all right, David, I'll be the client. I send you a SYN, hey, Mr. Server, here's my starting sequence number. And there's an action that you're going to take when you respond. You're going to add 1 to the sequence number and respond +1. What that does is it allows me to know that you heard me. Yeah, in the handshake, it's called a ghost byte. It's not a real byte of data. It's not a true, actual byte that I needed to send. But what you're going to do is you're going to increment the sequence number by 1, and then you're going to send me back an acknowledgement number +1. So let's do this. Let's just remember this 7413 right here, okay? Take a look at our SYN-ACK. I'm just going to come down and take a look at now, the acknowledgement number in the SYN-ACK. So 7414. Okay, I'm going to do that again. All right, let me go back up to my SYN. 7413 here, and then you come back and you say ACK, but +1. All right, so what does that do? Now, the relative ACK number is a little easier to use. You're just taking the 0 I sent you, the quote-unquote 0 from the Wireshark perspective, and you just added 1 to it. So what do I know now? If I'm a client, first of all, this SYN-ACK just gave me a bunch of information. David exists. I can route to David. David heard me. Right? He's got space available on port 80. He's got resource to accept a new connection. He went ahead and added 1 to the sequence number I sent him. So we're synchronized. As far as I'm concerned, you just act my SYN. I'm now good. I'm now perceiving that you're there and we can chat. Now there's more going on beneath this, but I'd like to stick on this for a moment just because it's so important. So you can see the amount of things I've learned. What else have we learned from the SYN-ACK that you sent me? If I come up here, let me take a look at my delta time. My delta time is the amount of time I have this set up in Wireshark. It's the amount of time between packets. All right, now that's something that's pretty simple to set up. This is something you want to make sure you do in Wireshark. I'm just going to come up to Wireshark Preferences. If you're in a Windows system, we're going to go to Edit Preferences. Let me jump there real quick, and I'd like to show you. If I go to Columns, all I got to do is I just got to add a column. let me just go delta. And then for the good viewers, you just come over here to type, and then we're going to come up to delta time displayed. And then once we have that, I just like to, as a style thing, I just like to move this up next to the running time that I have there. I'm going to remove this because I already have one. But basically, delta time is a great column to have when you're doing this analysis. So now what I know, David, is you, in time, are 20 milliseconds away from me. So that's nice to know. You agree?
Yeah, yeah. It's not a server on the other side of the world.
Exactly. Yeah, and in fact, I can take this 20, and what else can I learn about David? Well, I can come down here to IP, I can expand this out, and I can go to TTL, and I can go, whoa, okay, 238. Now, we talked about this in a previous video, but right now I know David, he probably started his TTL, his IP TTL at 255, because this number never goes up. So it's likely he began at 255. Now I can, look at the math on how far away you are, right? You're probably 17 hops away from me. Another possibility is that this started off on a completely different other number, but it's very unlikely. It's most likely that you started at 255. And
what are the numbers that we start at normally? Sorry, for the people who didn't watch the other video.
No problem. 64, 128, and 255 are the most common starting TTL values. In fact, let's test that theory. My machine, when I sent out the SYN to you, let's go to packet 1.
So in this video, I want to walk through a very simple connection between two computers here. So what I'm going to do is I'm going to connect from 192.168.0.147. I'm going to make a TCP connection to 192.168.192.10. And so usually the device that is initiating the connection is called the client. And then the device it's connecting to is called a server. But of course, once they're connected, it doesn't really matter who connected to who. They can both send data bidirectionally. And so what I'm going to do here is I'm going to start this connection from port 56208, which is just kind of a randomly selected port, and I'm going to connect to port 13 on the server. And then what's going to happen is the way this server is set up is when you connect to port 13, the server is going to send back just a little bit of text that has the time of day in it, and then 208, which is just kind of a randomly selected port. So in this video, I want to walk through a very simple connection between two computers here. So what I'm going to do is I'm going to connect from 192.168.0.147. I'm going to make a TCP connection to 192.168.192.10. And so usually the device that is initiating the connection is called the client. And then the device it's connecting to is called a server. But of course, once they're connected, it doesn't really matter who connected to who. They can both send data bidirectionally. And so what I'm going to do here is I'm going to start this connection from port 56208, which is just kind of a randomly selected port, and I'm going to connect to port 13 on the server. And then what's going to happen is the way this server is set up is when you connect to port 13, the server is going to send back just a little bit of text. So we've looked at how we can use IP to send data from one computer to another, but there's a limitation to how much data we can send at one time. So remember, the IP packet has to fit inside a data link frame. So an Ethernet frame or PPP frame or something is usually limited to carrying at most like 1,500 bytes or so of payload. So if we want to send a file that's larger than 1,500 bytes, an obvious solution would be to split that data up into multiple packets. But there are a couple challenges to doing that. So The first is that it's always possible for a packet to get dropped somewhere along the way. So we've got packet loss. And this could happen because of some physical layer or framing issue where, bits are being interpreted incorrectly, or there's some corruption on the line. It could also happen occasionally because of routing protocol changes while a router is updating its routing table. But if we lose one packet from our stream for any reason like this, then the rest of the packets that we do receive might not actually be that useful. So we want to be able to recover from this to sort of detect loss and retransmit any packets that we've lost. Second, it's also possible for packets to arrive in a different order than they were sent. So we could have reordering of packets. And that could happen, for example, if packets are arriving at Denver here, destined for host B over here, and Denver might have two routes. It might send some of the packets this way, and it might send some of them this way. And when they arrive in New York, they could end up getting interleaved into a different order than they were when they were sent. And so host B over here would have to be able to handle that reordering and put them back in the correct sequence. Also, there might be many conversations going on between two computers. So we need some way of knowing that when computer B over here receives a packet from computer A, which conversation does it go with? So we've got multiple conversations. And so, for example, if B is transferring two different files from A at the same time, how do we know which packets are part of which files? And then finally, if we have a lot of packets that we're sending between these two computers, it might matter how fast we send them. So for example, if computer A over here is sending packets as fast as it can, what happens if this link between San Francisco and Denver is operating at a lower bit rate? Or what happens if there's also packets coming from Seattle headed this direction? What could happen is that this link could become congested, and then the San Francisco router is going to end up dropping some packets. So it'd be nice to have some sort of flow control here. So flow control that can tell A to slow down if there's too many packets being dropped. And so in this video, I want to talk about TCP, which is the Transmission Control Protocol, which actually solves all of these problems for us. And so it does that by providing what's called a byte stream service, which is connection-oriented, and reliable. And I'll explain what all this is in just a minute here. And so by connection-oriented, what I mean is that before sending any actual data, host A has to establish a TCP connection, a transmission control protocol, a TCP connection to host B. So this is sort of like a phone call where, before anyone can talk, you've got to dial the number, wait for the other person to answer and say hello, and then you can start the conversation. And so there's a connection setup process that takes place first. And when we say byte stream service, what that means is that once that connection's established, either side can then just send a stream of bytes without having to think about how they're broken up into individual packets. So, one end over here can just put a stream of bytes into TCP, and then the same identical stream of bytes is going to just appear at the other end. And so it doesn't matter how long that stream of bytes is, because TCP is going to automatically break that up into smaller segments, each of which fits into an IP packet. And so then when TCP receives data at the other end of the connection here, it's going to send an acknowledgement back. That way, if the acknowledgement isn't received after some time interval, then the data can be retransmitted. And that's one of the ways that TCP provides reliability. So it also keeps track of the correct sequence of each segment that it sends, so it can put data back in order when it receives it and remove any duplicate packets that show up, just to ensure that it's providing that reliable connection and providing that byte stream service between both ends. And so now I just want to take a closer look at the actual format of the TCP packet. So the TCP data is going to be encapsulated inside an IP packet, which is going to be encapsulated inside some kind of layer 2 frame. So again, if we have an Ethernet frame here, the payload, the ether type is going to be 0800 because we're encapsulating IP inside Ethernet. And so then this payload is going to include the IP and the TCP data. And so if we take a closer look at what we've got here, the IP header we've looked at before, so that's going to have our source and destination IP addresses. So that's how the routers are going to know how to route this packet. And then it also has the protocol. And if we're using TCP, this protocol is going to be set to 6, because 6 is the protocol number for TCP. So anytime you see a 6 in the protocol field of the IP header, then we know that we're dealing with a TCP packet. And so then if we come down and look at the TCP header, a couple fields that I want to point out is the source and destination ports. These two fields here, these are used to uniquely identify the particular connection that's taking place. So remember, we've got two computers. So we've got host A and host B over here. So if this is A and this is B, you're going to have, if A is sending a TCP packet to B, you're going to have A's address as the source address, and you're going to have B here as the destination address. But then you're also going to have a source port and a destination port, because A might have two connections to B. And in order to tell those two connections apart, you're going to use these ports. And so, for example, one of these connections might be port 1, 2, 3.
Bro, I think I'm not ready to go into depth of this. I think so. Firewall concept, network topologies, bus topology, star topology, ring topology, stuff like that. Network topology. Yeah, I knew that. Mesh 2, bus stop 3. This is the first time I heard about 3, by the way. Not quite. Cancel. Closed. Cancel. Okay, I know this stuff like my back of my hand, bitch. And firewalls concept. VPN basics. Okay, I am user, I am groups, I am roles. Okay, firewall concept. But I use Nmap and this fucking firewall blocked it all out, bro. I was about to hack NASA, bitch. I use Nmap on this bitch and firewall deflected it.
Moving on, understanding the core concept of a firewall and how that works. Hey there, greetings everyone. Daniel Lowry with Anti-Siphon Training, and I'm back. I'm back with another episode in our Networking Fundamentals series, and today we're going to put the fun back in the fundamentals because we're looking at firewalls. We're going to try to figure out what is a firewall, what does it do for us, and how does it do those things? What are the different types of firewalls that I need to be familiar with? That's all in today's episode, so let's get cracking because there's quite a bit of information for us to go over. And of course, your boy Vibe coded himself another infographic for us because that is a helpful thing for us to kind of move along with the information and make sure that I cover all the things necessary in today's episode. This one is Network Firewall Fundamentals, your digital gatekeeper for network security. And that does break out to that first question that's burning in our minds. What is a firewall? And a firewall, right here, it says it. It's a security device. Could be hardware, could be software. It is something that monitors and controls network traffic. It is looking at things and is making decisions to allow or deny that traffic based off of rules that we set up as the end user. So that's all the baked in little information right here with what is a firewall. It's just a hardware. It typically is a hardware device, but a lot of times you will see software firewalls as well. And it's doing that monitoring and controlling of that network traffic. And I put ingress and egress over here. We're going to get to more of that in just a bit. And of course, we create the rules. We create the policies that say, this is good traffic, let it in. This is bad traffic. Es no bueno, make it stop. Moving on, understanding the core concept of a firewall and how that works. To me, it's like a traffic cop, right? A bouncer. A lot of anything that does some sort of control over, I like the idea of a traffic cop really well because you can see traffic, right?
cars moving from one end to the other. The police person standing in front of them go, no, you stop here. I'm going to allow this traffic to go. I'm going to make this traffic stop. It is that very idea. Also like the one of a bouncer standing at the door. They've got a list of approved people that are allowed to come in or whatever. And then anybody that's not on the list, as they like to say, your name's not on the list. And then you don't get access to the club. Okay? So firewalls decide which traffic is allowed and which traffic is blocked. So I talked about it before, ingress traffic versus egress traffic. Ingress is simply just data or traffic that's coming into your network. Egress traffic is data going out of your network. Here's a little diagram of what that looks like. This is my best representation of a globe for the World Wide Web or in the internet. You can see this red arrow trying to make its way into your computer, your host, your network device. And it's saying, no, that traffic coming into that device, I'm going to block it. Okay? So that's data going into your... So maybe downloading a web page, right? Even if I've made that reach outs to a site and say, you know what, I need to download that specific item, or I just want to view your website, the firewall might say, well, we don't allow that, so I'm not going to... You might make the request, but I'm not going to allow the traffic to come back in. So that's ingress traffic. Then there's egress traffic. This is data going in, from your PC to the internet, out of your network. Could be going to other networks, but you get the idea. Typically, we're doing stuff on the internet. So this is data going out. Maybe you're sending an email, something like that. So where do firewalls sit? This is like I said, typically this is a hardware device. So there are a couple of different places in where this firewall could be positioned, because it does need to see that traffic coming in. All the incoming traffic needs to, at one point, flow into this. And of course, anything that's outside of that is not going to reap the benefits of the firewall being able to look and see, is this traffic malicious? Is it something that we just don't want because there's no reason for it? Could be just scanning, could be whatever. But if you're not inside that firewall, if you're not on the other side of it, where its blocking capabilities are going to be most useful, then you are at more risk. So most of the time we set this on the perimeter. That's what we have here, the edge, the internet gateway, right? So there's your internet right there in this little circle. There's your firewall in blue. And you see that it's got blocked traffic and it's got allowed traffic. That's the red and the green. And this square with all these little gray dots in them, that is our internal network. So it is acting as the gatekeeper of all internet traffic, all outside traffic coming in. It's looking at the rules and saying, is this allowed? If it's not, then we're gonna stop it. If it is, then we'll allow it. Okay? So then we also have internal segmentation. Maybe I want to separate two parts of my network out and make sure that traffic from one side doesn't make it to the other. So that could be a useful way in which we can employ firewalls to stop traffic from one area of our network to the other and filter that stuff out, right? Firewall separating different departments or zones within an organization. And then this takes us to our host-based firewalls, right? That we're coming from the internet, and you'll notice there's no blue firewall here. It's actually on the device itself. That's a software-based firewall. That's something that it's sitting on the host, showing you how to do this. And I actually brought up the Windows firewall. This is the Windows Defender firewall with advanced security. And if we get kind of zoomed in here, you can see that we have inbound rules, we have outbound rules, and we have monitoring going on. All of the telltale signs of a good firewall. Those inbound rules are going to be that ingress traffic, stuff that's coming in. All of these are rules that with the green check marks, and if you look over here with the action, it is showing you that these allow rules. These are things that it is allowing in. We can scroll down and see if there's anything that's specifically being denied. These are all the default rules in the Windows firewall, but you'll notice that this is all just allowing things. Okay? Now, we could be making deny stuff, but right now we're just making a allow stuff. Like we're allowing things to come in. These are typically called allow lists or whitelisting. You have deny lists which are blacklisting. We're saying these are the specific things, and just depending on what philosophy you want to take, and you can do both, right? Like what we see here is, at least with inbound and outbound, maybe you go one way, maybe you go the other. It's all up to you on how that works. But I did want you to see that, and we can create new rules, and we will come back to that momentarily. Okay, so let's jump back over. So now that we know where these things can sit, what are we moving on to next? Well, we got a few concepts that we need to understand when it comes to the firewalls itself. And I wanted to make sure that we got these because I didn't want to forget them. And these are these key concepts. Rules and policies. These are the instructions for traffic. I think we've probably made that clear. I haven't used the word policy, I don't think yet. I've been saying rules because that's more typical, but it is a policy. Sometimes you hear them as access control lists, and that is a very simplistic form of setting rules for your firewall. But it's basically, at the end of the day, your rules or your policies are the instructions for how the traffic is either blocked or allowed. Then you have this idea. This is a philosophy that you can implement as a policy, which is default deny. Block everything unless it is specifically allowed. That's an allow list style. So maybe you want to just say, you know what? The best way to go about this is probably just deny everything by default. And then when people complain about not being able to access stuff, we know that we should allow that, and we'll make a specific rule to allow that traffic. And that way we do not miss anything, because if you go the other way around where you allow everything and only deny specific things, well, now you got to be really on top of what you're supposed to be denying, which is an ever-changing thing. So it's really difficult. And those goalposts are moving constantly. So it's difficult to stay on top of what you should be allowing if you go that way, if it's all allowed, only denying specific things. So it's easier and probably more effective to just deny everything by default and then allow the things you know are legit. And don't worry, if you're one, will we catch it all? Someone will complain if it's not allowing. They'll be like, I'm trying to use this program and it can't work. It's telling me maybe it's a firewall rule. That is typically right. So then you'll know about it because the users will complain, which might be you. All right, then we have the ideas of stateful versus stateless firewalls. This tracks connections versus treating each packet individually. So stateless firewall just says, hey, I've got a rule of if it's coming from this source or this destination, or it's going to this destination, or it's looking at this type of traffic, maybe it's TCP traffic or it's UDP traffic, and it's going to this port, block or allow, whatever I'm going to do. Stateful firewalls, on the other hand, look at the connections. Is this a legitimate connection? If it is, then I can allow it. If it's not, well, then I'm going to block it. So it's a little more intelligence going on there. But you do need to be familiar with both stateful and stateless firewalls. All right, and that brings us to the idea of types of firewalls, right? So starting off with those type 1, first gen, packet filtering firewalls. Examine basic packet info. What IP, what port, what protocol, right? Going to the idea of that bouncer, right? Checking IDs. Let me see your ID there. Yep, 21, cool. Go on in. We get that ID? Yeah, 21, cool. We go, oh, you're 19. You can't go. I'm sorry. Nice try. You're old enough to, do other things, but this ain't it. So here you go. Enjoy your night. And they deny access. That's the same idea of a standard packet filtering firewall. So just keep that in mind. They are simple. They're fast. They're low cost. A lot of pros to them. They're built into a lot of firewalls by default. But there are some cons, some limitations, right? They have limited context. They don't really know what's going on. They're vulnerable to spoofing. They have zero application awareness. So these are very basic firewalls. So you just got to keep that in mind when you're employing them. That doesn't mean they don't have their area. They don't have their space. You just have to know that it might not be everywhere. You might not just get away with using these. You might need something more robust. Let's get back to it. And if we look, we see we have stateful inspection firewalls, second gen. Yay, we're going to maintain a state table and track active connections. If I have a browser, I make a connection to a web server out on the internet, it's tracking that connectivity. Hey, something from the inside requested traffic from the outside. It's establishing a connection with something outside of here. I'm going to make a little note of that. I'm going to write that down. That seems interesting. So when that traffic makes its way back and it tries to return the request that was given, it doesn't go, well, what is this, buddy? It doesn't have to. It knows that that's a legitimate connection and that state should be allowed. If some random site decides to send you traffic that you have not requested, it's going to go, oh, what's that you got there? You're a cutie. But no, thank you. And it'll block it because you don't have a connection. You don't have anything that makes sense for it to allow that traffic to go through. Right? So there's your analogy of a bouncer who remembers who entered. So Bob and Sally go to the club last night. They got their IDs checked. Bob and Sally go in. They have a great time. But anymore. He knows who they are. Connections, right? Because it doesn't have to keep rechecking things. It knows those connections. It's already done the hard work. The cons are it's a little more complex. And it's still limited in its application visibility. Okay, let's keep going. Proxy firewalls. Interesting stuff. This is third-gen things. Acts as an intermediary, inspecting traffic at the application layer. So you might see this as an application layer firewall. You hear that. The analogy now is of a concierge who handles and inspects requests. Yes, Mr. Bill. Yes, Miss Sally. Let me get that for you. They make the requests, and the concierge does it for them. Just like a firewall. If I wanted to get to a website and I wanted to get that traffic, I would make the request. The proxy would intercept that request, look and see where's it going, what kind of content, what's happening, is anything in there on the deny list? Does it make its way through that? If it does, cool, grabs the thing, brings it back, and then hands it to us. Does that make sense? So it's a proxy. That's the idea of a proxy. So pros and cons. Deep packet inspection, we like. Application aware filtering, very cool. But the cons are performance overhead. You're going to hit some latency with these things just because it's doing a lot under the hood, checking all these things. And it is application specific. It's got to know about these different applications and what kind of traffic, because it does a lot of content filtering. Okay. So when you think proxy firewalls, a lot of times you're thinking of the idea of A, it doing the requesting for you, and B, filtering based on content. All right, 4. Next-gen firewalls, NGFWs, combine traditional functions with advanced features like IPS, which is intrusion prevention systems. You have application control and threat intelligence. These are the big dogs on the block at this point in time. The analogy is a highly intelligent security system with behavior analysis. They're like the FBI's BAU. They're like, well, I'm watching and I'm profiling everything that you do, and I'm building a profile of this seems like malicious activity. And because of that, I can actually stop it because it probably has intrusion prevention capabilities built in. So it is vastly superior in intelligence, sophistication when it comes to what it can block because of what it can understand when it comes to your traffic. Very cool stuff. Has its pros and cons though, like anything. Pros, comprehensive security. Protects against modern threats. This we like. Cons are, it is more complex. Much more complex. So getting those things tuned just right is a much harder. Higher costs, going to cost you a bit more money. And it's also going to be resource intensive. That's why it's typically an application like an actual box, physical box, has its own dedicated CPU, RAM, so on and so forth. You rack and stack that thing, connect everything up the way it's supposed to be, and then you should be good to go. Okay? All right, moving on. How a firewall works, or how firewalls work. Rules and policies, right? Been talking a lot about rules. We need to kind of get into how those rules work. You've probably picked up a little bit so far, but let's hit the highlights here. Firewalls process rules in a
I can tell that this whole series AI because of analogy
specific
of a rule.
order, typically top down. It means it's got a list of rules. It starts at the top and works its way through each one of those rules. If whatever the traffic is and its context, and all the little bells and whistles about it, if it hits on any of those things, then it will key that rule to go into effect. That could be an allow rule. That could be a deny rule, right? And that's the important thing. If I have an implicit deny, if I have a deny by default policy, where rule number 1 that I created was deny everything. Now I need to build another rule that goes above that rule that says, well, if you're going to our web server, you can allow that. So then it looks at the traffic. Where is this headed? What's the destination? Is it the web server? If it's not, it doesn't meet the criteria and it discards the packet or it denies the packet. Is it headed for, okay, it is HTTP traffic. Is it headed for the right port? Is it TCP, right? Does it meet all the criteria that I have set to allow for access to the web server? If it doesn't, it's getting dropped. If it does, well, come on in and enjoy web services, right? So you got to remember, it's always top down. It's, well, not always, but most of the time you're seeing that top down, starting from the beginning and setting those rules in the right order. If you're going to get someone that's calling you and saying, I'm having trouble accessing the web server, we need to take a look at their request. What's going on? What are you doing that would stop this? And let me do the analysis of how does that line up with the rules that we have in place? And why is it getting popped? Why is it getting denied? And maybe you need to make an adjustment, right? So there you go. So it's going to match rules and then take action. Anatomy of the rule. Things like source. It could be the source IP, the specific host IP itself, or just the network that they're from. We could be allowing or blocking things based off of the network that they're on, or the specific user that is sending traffic if it's going to be application aware, things of that nature. Destination. IP. Again, same idea. Okay, where's it going? Where's it coming from? Who are you? Give me your IP.
I've been seeing
Tell me what network you're on. Tell me what service you're using. And I can block any of those things, or all of them. Protocol. What protocol are you using? TCP, UDP, ICMP, you name it, it could go on there. What port are you looking to get at? Port 80, 443, 22, typical web, typical SSH, maybe it's RDP 3389. Any of these things. And I can control with my firewall out here. Go ahead. Okay, what's the difference? See, not get access to it. And between the two things that you should be aware of. So if you're looking at a deny or reject, it's actually going to tell the user in some capacity, in some way, depending on how you're trying to make access, that there was an error. You're not allowed to access this. This is denied. You cannot go here. It's going to respond to the request. Whereas drop, it just ignores it. It just goes, packets on the floor. I don't acknowledge them. They're just nothing. And you might be wondering, well, who cares? Well, what does it matter whether I tell them they've been rejected or if I just drop the packets on the floor and give them nothing back? Could be that if you tell them you're rejecting their packets, they know that they're hitting a firewall. If they're an attacker, now they can start trying to figure out a way around the firewall if that's at all possible. Whereas if you just drop it, it could confuse them a little bit and say, okay, is this just a closed port or am I hitting a firewall? Hard to tell. Because a closed port might just drop packets. And they're going to have to do a little more work to figure out whether or not that port is actually open and being reached. And the firewall is in place and it's filtering.
Or unmap that should like drop
if it's just closed. Right? So that slows them down, increases their ability of getting caught, right? Or the chances are that it is that they get caught.
Okay. All right. Firewall concept. VPN. Not this. I haven't seen like in depth, but VPN. He's an Indian, I can't tell, bro.
What is a VPN? So that is the topic of this video. Now VPN stands for Virtual Private Network. A VPN is what establishes a secure and reliable network connection over an unsecure network such as the internet. It protects your internet activity and disguises your identity as you surf the internet. So for example, when you order internet service from your ISP or internet service provider, they will set up your internet connection. And when your setup is complete, your internet activity is routed through your ISP servers, which means that your ISP can see and log all of your internet activity. So they can see every website that you visited. Now typically this wouldn't be a problem if they kept your internet activity private. However, there is a possibility that your ISP could share your information with other third parties, such as advertisers or maybe even the government. And if this were to happen, your internet activity is no longer private. But by using a VPN, your online activity will bypass your ISP server and will be redirected to another server, which is a VPN server, which means that your internet provider or any other party can no longer see what websites you are visiting. The VPN server is now your source where all of your internet activity goes through. And this has several benefits. And the first benefit is that a VPN will disguise your identity by hiding your IP address. Whenever you order internet service from a provider,
I would like to synchronize with you. Acknowledged. Synchronize session 59. Acknowledged. Oh. Alright. Yeah. Uh-huh. Hold up. Hold up. What happened to 62? Which one? 62. Oh, this. Okay, here you go. Here you go. Yeah. Yeah. Yep. Well, out of order. Out of order. Reset. Acknowledged. I would like to sync.
Hi, can I help you?
Can I have a large iced coffee?
Sure. That'll be 3.
I don't know. Come on.
they will assign you an IP address. That unique IP address is attached to your home or business. So whenever you visit a website, that website can see your IP address. But when using a VPN, websites can no longer see your IP address. They now only see the IP address of the VPN server, which effectively hides your identity so you can surf the internet anonymously. Another benefit is that a VPN will encrypt and protect your internet data. Whenever you go on the internet, the data that you send and receive is broken down into a bunch of smaller data packets. These data packets travel across the public internet and ultimately find their way to their destination. But as they are traveling across the internet, your data can be viewed by ISPs, governments, and it can also be intercepted by hackers, especially if you use public Wi-Fi networks. But a VPN will prevent this. A VPN will encapsulate each data packet by adding an extra layer of protection to each one, which is known as tunneling. This extra layer adds a layer of protection to ensure your data is secure and kept private as it travels across the internet in a virtual tunnel. So any activity that you do on the internet, such as visiting web pages or transferring files, the data is encrypted and kept private when using a VPN. And third, you'll be able to access internet content that would normally be restricted in certain geographical locations. So for example, some internet content, such as videos from YouTube and Netflix, may only be accessible pick from different VPN servers that are available in different countries, which changes your IP address, which effectively changes your location, which will give you access to restricted internet content. So if you're in South America and you wanted to access certain content that's only available in the US, you can use a VPN and choose a VPN server that's located in the US, so you can access that content. And a fourth benefit of a VPN is that it provides a secure connection for remote workers. So as an example, some businesses may have employees that work remotely from their computers at home, and they need those employees to have the ability to access files at the main office. Now this could be done by using a leased line. A leased line provides a dedicated channel that can connect two sites together through a reserved private circuit. These lines are rented for a monthly fee, and they can be expensive, especially if the distance between the two sites are far from each other. But instead of using a leased line, businesses can use a VPN. A VPN uses the existing public network, such as the internet, to establish a remote connection. And when a VPN is connected, it acts like a secure private network. It provides a dedicated link between 2 points over the internet. So even though this office and this home are in 2 separate locations, it doesn't matter. A VPN makes them one private network virtually. So who would need a VPN? Well, a VPN is for anyone who wants to be extra safe on the internet. It reassures that you're surfing the internet safely, secure.
Hey, what's up guys? Welcome to Cert Bros. In this video, we're going to be looking at VPNs.
What the fuck is the intro, bro?
Its job is to ensure the safe delivery of data across public networks. By doing this, it allows the user to send data as if they were directly connected to that private network. Let me show you what I mean. Let's say this is your head office. Now your head office is where all of your business critical servers and applications are located. As well as your head office, you also have a smaller branch office. The smaller branch office also needs access to your business critical servers and applications. There are different connectivity options available to you. For example, you might use a private MPLS network. This would be a great option. However, it comes at a price. Internet access, however, is very affordable. But there is a problem with that. The public internet is full of bad guys, and these bad guys are just waiting to get their hands on your company's sweet, sweet data. One solution is to use a virtual private network, or VPN. A VPN is often described as a tunnel. Your data is encrypted before it passes through the public internet. This way, if one of the bad guys does get their hands on your data, they won't be able to make any sense of it. Once your data is received, it can then be decrypted using a special key, so it can be read as normal. There are 2 main types of VPN. The one you see here is known as a site-to-site VPN. This VPN connects one entire site to another entire site, and is always active, meaning it's always on. A site-to-site VPN needs to be configured on both networks, so it's ideal for situations like this when you have multiple remote sites. But that's not always the case. You may have individual users that work from home, coffee shops, or anywhere else in the world. These users still require access to the corporate network, but a site-to-site VPN won't work because you have no control over the networks they're connecting from. Instead, they can use the second type of VPN. This is called a remote access VPN. A remote access VPN grants access to the corporate network, but only for one device, for example, a user's laptop in a coffee shop. This is unlike the site-to-site VPN, which connects to entire networks. Okay, so now we know what a VPN is and the 2 different types. Let's look at each in a bit more detail. First, let's start with site-to-site VPNs. Here we have Site A and Site B. Both sites are connected to the public internet. Site-to-site VPNs are typically configured on either a router or a firewall on both sites. A popular site-to-site VPN is IPsec. IPsec is a framework or set of rules for creating VPNs over a network. It does not define any one way to create a VPN, but rather allows several protocols to be used for each VPN feature. IPsec is often used for site-to-site VPNs, but it can also be used for remote access VPNs as well. Once the VPN is established, all devices on each site can send data securely over the VPN. So how does this work? Well, let's say a host from Site A sends some data over to Site B. The router will look at this data, see that it's destined for Site B, and realize it needs to send this over the VPN. Before it can send it over the VPN though, it first needs to encrypt the data. It does this by taking the original data and then the encryption key to produce the encrypted data. Let's take a closer look at this. When the IP packet is received, it is put through an encryption formula along with the session key, which was exchanged previously. Once encrypted, the router then encapsulates this data with the VPN header and trailer. Then it adds a new IP header. This new IP header will have the public IP address of the remote site. Now there is a bit more to it when it comes to VPN headers and trailers, but this is the general idea. When the router sends the encrypted data, the data will make its way over the public internet safely to the remote site. Then the encryption process is reversed. Again, let's take a closer look. The router receives the encrypted packet. Using that session key that has already been exchanged, the router can decrypt the data back to the original form. From there, the router can forward this packet onto the destination. Okay, so that is a site-to-site VPN. This is great when you want to connect one or more offices together. Sometimes, though, you need users to be able to connect to the corporate network from anywhere in the world. This could be a coffee shop, on the train, or working from home during a pandemic. For this situation, a different type of VPN exists. Remote access VPNs. A remote access VPN allows a single device to connect to a corporate network. This could be a laptop, desktop, or even a smartphone or tablet. Just like a site-to-site VPN, a remote access VPN allows a host computer to safely send and receive encrypted data over the public internet. This is great news if you're connecting to a public Wi-Fi where you have no idea about who could be snooping. Now, unlike site-to-site VPNs, which are always running, remote access VPNs require an application on the host to connect back to the corporate network. The corporate network will be listening for these connection requests. An example of a VPN client application is Cisco AnyConnect or OpenVPN. Here is OpenVPN running on my computer. While IPsec is used for site-to-site VPNs, TLS is usually used for remote access VPNs. TLS is the same security protocol used to encrypt your web traffic when connecting to HTTPS sites. It's also handy because some public Wi-Fi might block IPsec ports, whereas TLS usually uses well-known port 443, which is generally allowed. When configuring remote access VPNs, you need to decide if you want to use something called a full tunnel or a split tunnel. What does that mean? Well, a full tunnel means that once connected to the VPN, all traffic from the host will be forwarded to the corporate network. Even if you're just browsing Facebook, this will all be tunneled through the corporate network. This is great if you want to enforce your corporate firewall policies. Now, a split tunnel means that only traffic destined for the corporate network is sent over the VPN. All other traffic is routed as normal. This is great to save bandwidth and also provide a bit more privacy to your users. This is sent over the VPN. All other traffic is routed as normal. This is great to save bandwidth and also provide a bit more privacy to your users. Which one you choose is really up to you and your security needs. Now, just before I end this video, I do want to briefly mention VPN services. In recent years, several companies have emerged offering VPN services. That promises to keep all of your internet usage private, secure, and away from hackers. You've probably seen their adverts. These are like remote access VPNs. You connect to that company's network before they forward it over to the internet. By using these services, the idea is that only the VPN provider will see your traffic. So not even your ISP can see what you're doing. Now, while there are some understandable reasons to use these services, please don't get sucked into some of the scare tactics that most of them use. Anyway, how they work. So please feel free to go and check that out. If you like this video, then don't forget to give it a thumbs up, leave a comment, and subscribe.
Identity access management. Okay. So service, BPC service. Where the fuck is the bucket then? Here. Okay. Okay, I can't do this right now, bro. I'm way too tired. So let me do Hyperland, which I enjoy, bro. I like to learn things about Linux and not Linux, especially, but about modifying. So I will be back in a sec. So I know I'm gonna be back in a second. So watch this shit. Hear this shit. The fuck? boys. So for software development bits.
After trying out Ubuntu a couple of weeks back on a virtual machine on my MacBook Pro, a lot of you recommended that I should try Arch Linux with Hyperland instead, and that's exactly what I decided to do.
Ding, ding, ding. this app? Why is this?
It took me a long time, and it was a bit painful to set up, but I've been having a lot of fun. I absolutely love my new setup. D-Link was kind enough to send me their new SCR9 Max mini PC, and it's been the perfect little machine to get Arch set up in case I have to access Windows again in the future. This all file system and installing all of the packages. You package manager, workflow. It's a dynamic tiling compositor built for Wayland, which basically means it'll automatically tile and arrange the windows that you open on your screen. I've configured Command T to open new terminal windows. As you can see, it'll automatically tile and arrange them. Hyperland has some nice animations, and it allows you to make things look really nice. I like the rounded borders, and as you can see, the window in focus will have this blue outline around it. I can do Command L to go to the right and focus, Command H to the left, Command K to go up, and Command J to go down. To close the window, I've configured Command Shift Q. As you can see, there's some really nice animations there. Hyperland allows you to create a powerful but simple keyboard-centric workflow, which I've been really enjoying. I've configured Command plus a number to change to a different workspace. So I do Command 1, I'll go to workspace 1. I have a terminal screen open here. I'm going to increase the font here. The Hyperland config is in ~.config/hyper/hyperland.conf, and this is where you configure everything. I found Hyperland to be pretty easy to learn, and it's pretty simple to configure as well. This is where I've defined all of my different keybinds for everything that I want to be able to do in my setup. If I do Command B, it'll open a new browser window. Command M will open Spotify, so on and so forth. I can do Command V to toggle a floating window. If I do Command and left-click, I can drag that window around. Command group, then I different mode, the keys will do something different. If mode, the keys will do something different. If I do Command Shift W, this allows me to change the wallpaper. I'm using a tool called W Paper D for this, and if I do L, I can go to the next wallpaper, and H to go back in the other direction. I've configured Waybar to show this icon here, which will let me know that I'm in this different mode. I also really like that you can use CSS styling to configure how Waybar looks, which is really like that you here, which will let me know that I'm in this different mode. I also really like that you can use CSS styling to configure how Waybar looks, which is really convenient for me as a web developer. If I press escape here, I'll exit the submap and the icon goes away. I also have a different submap with Command Shift P, which will allow me to power off the computer, log off, reboot with different keys on my keyboard. Again, if I do escape, it'll exit that. Again, if you want to see an in-depth video on how to set up all these different things up yourself, let me know and I'll consider doing several different videos about all this stuff. I really love how much control I have over the operating system. I mean, even my mouse cursor is a custom cursor that I found on GitHub called Bibata. And the combination of using Hyperland with Waybar, I think makes everything look really nice. I'd also mention that using the Yay package manager has been a joy to use. You can just do Yay-S followed by the name of the package that you want to install. If you use -RNS, you'll remove it. You can also look for packages by using Yay and then type the partial name of a package. For example, my cursor is Bibata, and it'll show me different options for what I could install. For software development specifically, I feel like this setup is pretty much all I need. For video editing and doing other work, I'm still going to need my MacBook, and also for working on the go, as this setup is currently just on the mini PC, which I use at my desk. And as I mentioned earlier, I'm using the Beelink
Okay, how to hyperland, bitch.
Hi, and welcome back to the channel. My name's Drew. This is Just a Guy Linux. And as most of you know, I am generally working with Debian stable all the time. And in fact, I don't really deviate from the Debian packages or the Debian repos. So I am not using the most up-to-date software basically for anything, which is fine with me because, like, I mean, you know, I use BSPWM and I don't think it's been updated since Bullseye. And not to mention the fact that I don't even use like tools like Kdenlive or anything like that. Regardless, I am still interested in stuff that's really kind of cool looking to me. And Hyperland was one of those things. Not to mention, a lot of you have asked about Hyperland in the comments. And so today I'm going to try and use Debian testing to build Hyperland. And so what you're currently looking at is Hyperland running on my test machine. Now it's on Metal, so it's not on a virtual machine. So I did it once. And so what I'm going to try to do is replicate that now. So I think the best way to do this is just to wipe the whole thing, start all the way over again. And that's what I'll do right now. So anyway, I'm going to sudo and I'll start from scratch. Now I'm just using the regular Bookworm network installation.
Dell, same as mine.
So what I'm going to do is, and I've done this many times, so if you need to pause, feel free. But I am going to try to do this in about, I don't know, and back in the, and it'll be good. Let's do this. I'm going to create. I will use this as EFI. Because there are seconds or whatever. And yes. And hit continue.
What is it
And
gonna
I'm just
do?
going to install the standard.
Oh, there is no Bookworm, bitch.
I am going to take those out, and I'm just going to install the standard. And
Command
I
cell?
am going
What the fuck?
to take those out, and I'm just going to install the standard utils.
What the fuck is Bookworm then? What is Debian Bookworm? I'm kind of interested because this is my OS. Okay, 12.
All right, here we go. Should be only another half minute.
Just to make. It does. Okay, what the fuck? Match your compatibility. So medium, very low. Risers, enemies and lovers. Okay, bottom line, if you're happy with available order. Okay, predictable windows. Need to search this in YouTube. Niri. Okay. I don't like that, bro. Bro, I'm just gonna be a hyperland bitch. So he has.
And, all right, back, and let's log in. And so sudo, and I am going to pause for a second.
What?
All right, back, and let's log in. And so sudo dpkg reconfigure console setup. And let's do this, and let's go all the way down. And there you go. Okay. So let's sudo apt install micro ZRAM tools and git, and that should do for now. Okay, clear the screen. And so actually, let me just go ahead and do this real quick. I'm going to say sudo micro etc default ZRAM swap. And so I'm just going to set up my ZRAM. And Control S, Control Q. And now what I'm going to do is sudo micro etc apt sources list. So we've got Hyperland in the session, and anything with the Q should open. Oh, I just want to actually let's go ahead and open up.
What the fuck is he even doing, bro? Okay.
What's up, guys? My name is Tony, and today I'm going to give you a quick and painless guide on installing Debian from the command line. The next time an Arch user tells you they are superior because they memorized 12 commands to install their system, you can tell them that you also memorized those 12 commands, but you can sleep at night better, because your distro is not old, but it's stable, and theirs is both old and unstable. Alright, so we're going to head over to Debian.org here, and we're going to click Other Downloads, because we're not going to be using the default ISO here. We're going to check out Try Debian Live before installing. We're actually going to use a live ISO today, so we'll click Other Live ISO.
If you've been watching any of my videos lately, you might have noticed that I've been using Linux for quite some time now. I mean, I freaking love Linux. I think it's amazing. It's a great environment not only for programming, for programmers like myself, but also for just customization and flexibility overall. I mean, you can install Linux on a freaking toaster if you wanted to. And my favorite way to customize Linux is with using a tiling window manager.
This looks so awesome, man. My mind is blown, bitch. The fuck, man? What the fuck? Dang. What the fuck? You got this shit here? What the fuck? Okay. Okay, Haberland, I got you, bitch. I'm gonna learn you. Hall of Fame. Fantasy. Okay. Is this Pop OS? Hey, Arch. Um, 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 dang, bro, this website looks so cool, bitch. Get started, bro. I want to learn shit. Okay. For the first time, this is the main tutorial to read. I like this shit, bitch. I'm gonna read you, bitch. The tutorial of everything you need to get things going. It links to other page where necessary. See the installation. Come back here. Okay, okay. This row not meant for full end user. In it's a set of allow you to create your own desktop environment application cell. Can't configure with very progress with high recommended. What the fuck is this?
Scour.
Scour. Nord out of the box. I got no NVIDIA. I got integrated graphics card, bitch. Movie office running this. Yeah, but I would work there for that. But you might have various amount of success. Blending is point out history like Pop OS, Ubuntu, but they are Debian based beds. Okay. How is this? Bro, this shit could ruin my shit. Bookworm is 12. I got 13. Okay, let me try this. I don't know if I should use this in my mean set. Like, I want to try it in another set. With the focus. This set is about to turn off. Do I see? Let me hit cat /etc/ Oh, I got Aaron. I got nothing. And user. Hyperland. I like the name Hyperland, bitch. Sudo and 65. Okay. Full name Aaron. Thing for that. Room number. Don't need. Yes. Clear. Okay. Okay, let's cat Hyperland Camgodras. Okay. I don't want to change my route, so I'm going back to that. So it might not look as sexy as this for now, but I'm gonna do my shit, bitch. So I'm gonna stop this and record in there and come back here. All right, bye bye.